Thank you. Thank you. So first of all, I would like to welcome everybody here up to the 5th floor of Clark. It's nice to see so many familiar faces out in the audience, as well as also certainly, of course, some new folks as well. So I've been here for about 3.5 years, and prior to that, I was a professor up at Boston University for nearly 30 years. And as in that capacity, participated in a whole lot of similar workshops down here, and certainly with the whole OCB crowd. It's one of my favorite groups. I was at NSF my last 4 years at BU, and it was really clear that these workshops and this overall organization are probably some of the most creative ideas that come out and flourish and get into the community. So really, I do welcome you and enjoy your couple days here. I want to say a few words about overall sort of ocean observing and how I see this sort of effort fitting in not only to what we do here at Woods Hole, but much larger to what's going on in the nation from the ocean sciences perspective. So as you all know, ocean sciences, we've been doing ocean observing for decades, all the way back to the Challenger expedition in the 1800s and so on. And as technology evolves, we bring different tools. I mean, and I'm talking real high level, like let's not go around in sailboats anymore, let's go around in diesel-powered engine, ships and so on. And then as technology evolves and we get into more distributed ways of gathering data like the Argo system, where we start getting more AUVs and ROVs out, and then we start developing different types of sensors that go here and there and so on. But only until relatively recently have we started to expand beyond just our own oceanographic cohort. And that's what's particularly exciting here about this workshop, in the sense of working with the commercial fishing community. I've been following this effort for many years, and it really speaks to a acknowledgement, probably late in coming, but certainly an acknowledgement of partnering with different sectors of knowledge, not just financial sectors or this or that, but different sectors of knowledge. My brother was a commercial fisherman out of New Bedford for about 15 years. I did. Whoa. I actually like my brother. I don't know why that happened as soon as I said him. If I was referring to my other brother, maybe. But anyway, so I only mentioned that in saying that, I'm very supportive and very knowledgeable of what the commercial fishing community brings to the table, and brings to the table not just in terms of platforms, but also intellectually. And this is one of several different groups that the oceanographic community and the atmospheric community are also starting to reach out to and train. In the old days, we somewhat patronizingly called it, citizen science or something, like there's a different type of science and there's like real science or citizen science or this or that. And that's not what this is about. This is about the community getting together and gathering the data, making the interpretations, and leveraging off of what we all know. The oceanographic community brings its certain strengths. The commercial fishing community brings their certain strengths. Other communities, like the Navy, they bring their certain strengths. And this is what it's going to take for us to collectively understand, the greatest challenges facing society today, whether it's, climate change or certainly, fishing interests specifically, or whole other aspects of the ocean and its overall environment. So I really, personally, in addition to welcoming you, completely support the work you're doing here. It fits into a large Woods Hole-led initiative called the Ocean Vital Signs Network, led by my boss, Peter Domenical, who's the president and director here. And if you look at that, OVSN, ocean, we all get that. Vital signs, I mean, I just had my doctor's appointment last month. I know what vital signs mean. And network is referring to you know, the engagement of different sensors, different vehicles, different communities, different contributors to understanding the vital signs of the ocean. And so I wanted to point that out to you, how this effort here as a focused workshop is really the tip of the spear of something much, much larger, not only here at Woods Hole, but also in terms of national and international trends of how science is going to be working for the coming decades. So enjoy your several days. I'm actually going back to another workshop over there I have to go to, and then in the afternoon, I wish I could come back here, but I have to write very important memos, which is pretty much what I do all day. So enjoy yourselves, and thank you for the opportunity to get you started, and have a great couple days. Thank you.
So my name is Heather Benway. You've gotten a lot of email from me just to hit my cards a little and tell you who I am. I'm an oceanographer. I've been here at WHOI since 2005. I started here as a postdoc, and I've gone out to sea collecting marine sediment cores. That was my gig when I was out there for 2 months at a time. We called it a floating asylum. Since 2007, I have been managing the Ocean Carbon and Biogeochemistry Program, which is the sponsor of this activity here today. And you're going to see up on that little board back there, we have other upcoming events that might be of interest to you at the intersection of ocean science and fisheries. And one of the workshops that we're holding is a virtual one next month, 2 months in March, that is focused on fisheries and carbon. And I strongly encourage you to take a look at it if you're interested. Fisheries and higher trophic levels in general, and their intersection and interaction with climate, with changing ocean conditions, are a growing issue, a growing field of interest in OCB. So you can look forward to a lot more great things, and I hope to foster a lot more stakeholder interaction and knowledge exchange using the OCB platform in the future. So I just want to tell you a little bit about what OCB is, what we do, just a couple slides, and then I want to kind of go through some of the logistics and give you an orientation of how we designed this workshop and how things are going to run. And then Alec will give a background and science introduction to the workshop. Oops. There we go. So OCB is really an incubator. It's an incubator that brings together chemical and biological oceanography perspectives, physical oceanography perspectives. You can see in green some of these big green icons. They reflect some of the different ocean topics that we're really interested in. These are kind of high-level topics that we're really interested in, and I really see fisheries playing a key role in a lot of these, especially the ocean carbon uptake, the biological pump, how marine ecosystems and food webs are functioning. And in this workshop, we're really exploring this ocean observing perspective. You know, how can we expand our coastal observing potential by leveraging our relationships with our fisheries? And commercial fishers bring a knowledge that oceanographers can't necessarily provide. They're there, they're in it every day. And there's a knowledge there that, you know, we can throw sensors in the water, we can do a cruise every 6 months, but, you know, we can't necessarily have that innate everyday knowledge of just being there in the ocean environment. Oceans are complicated, they move, they don't sit still. So it's really exciting to have this as a growing focus in OCB. We have 2 fisheries-focused workshops this year, this one and the one I just told you about. So you can see that OCB is really community-driven. The topics that come out, you know, people submit proposals to us once a year, activity proposals, and then we have a steering committee that decides which ones to support. And this was one of the ones that was selected to be supported. So clearly our community sees this as a high priority. I wanted to put more information in there. These slides will be made available for you if you want them. but you can find us online, you can email us, find us on social media, whatever your preference is. So just a couple of bullets on what we do. We host science activities like this, workshops, small working groups with, highly focused tasks, task-driven working groups, training activities, synthesis activities. We do a lot. We are involved in a lot of science leadership and science planning on all of the green high-level topics that you saw. We've contributed to high-level international and national planning documents. We have topical subcommittees as needed. Communication and networking, as you saw on that first slide, there's a lot to us. We have a website, we have a big social media presence. We're really kind of a centralized information source for the community of interested people in ocean carbon and biogeochemistry. Training and capacity building, we do a lot of support of early career scientists and training activities and travel support to really help launch the careers of new oceanographers, ocean scientists. And also education and outreach, FAQ documents and whatnot, infographics. So OCB has been around since 2006. We have a project office here with Whole Oceanographic. We're having that meeting here, which makes life easy because we know everybody and we can use the facilities here on the Hui campus. And let's face it, people like to come to Woods Hole. Maybe not in January, but we have funding. I want to be sure to acknowledge our funding sources right up front here. We receive funding for the project office from NSF and NASA. So those are the programs you can thank for today's workshop. And I want to thank Woods Hole Oceanographic because we receive a tremendous amount of on-the-ground support here and being able to use these facilities and set up meetings. We have an amazing catering staff and Chef Roland's group here. We have Matt Barton, who is up there helping us with AV. I want to say May Mahegan and myself are here from the project office, and some of you have probably conversed with Mary Zawoski over email. She is remote right now, but if you have any questions during the meeting, please come see us. I wanted to put up a quick slide about our code of conduct: no harassment, no bullying, play nice. It's okay to disagree, just do so respectfully. Let's listen to each other's ideas. This is really about exchange of information and ideas. That's what this is all about today. You can find that code of conduct on little QR codes around too. So if you have an incident, something really just rubs you the wrong way, click on that little, scan that code of conduct with your phone. It'll take you to a reporting page and you can report an incident and it'll only go to us project office staff, or you can pull me aside in the bathroom or on the stairs and I'm happy to work through it with you and address it. You probably saw when you checked in and got your name tag, we're using a red, yellow, green system for COVID. So please look at people's little stickers on their name tags and it will tell you how comfortable they are with contact with people. The restrooms, you've probably all found them by now, but they're right behind the auditorium. Wi-Fi, the password is right there, and it's also written on the whiteboard behind the thing here. It's also in the agenda, so it's all over the place. If you have any trouble getting connected, just let us know. I wanted to point out, and you've probably noticed it already, but there are some fishing gear, some model-sized, smaller scale models of fishing gear kind of distributed throughout the room. Feel free to touch it, look at it. Jenny has gotten these on loan, I think from Scarfo. So if you have any questions about the fishing gear, please just ask. This is a hybrid meeting, so we have a lot of people online who are tuning in, so I really want to remind you to wait for the microphone. Any of our speakers, you're going to be mic'd anyway. Any of our panelists will have microphones. If you have a question that you want to ask in the audience, please wait for us to bring you the microphone. For those of you who are tuning in online, you will type your questions into the chat and I will read them out for you. Or if you really want to be unmuted, we can let you speak the question yourself. And I also want to point out, so tonight we're going to have our workshop dinner at 5:30, but the program ends for the day at 5 o'clock. And so between 5 and 5:30, we're going to have beverages. And I'm going to encourage those of us here in person to grab a beverage, come back to your table, and between 5 and 5:30, we're going to engage with our online participants. So they're going to have an opportunity to come on, introduce themselves, share anything they want to share, and they can interact with us a little bit, which we think is a really nice opportunity to get to know who's tuning in with us online. So if those of you online know that you want to speak and say something, please just chat the host so that we know and we can look for you and unmute you and make sure you're visible on the screen. And we'll have a little mixer, I guess we'll call it. Just a little, this is my last slide. You've seen QR codes around. There's in that upper corner. That will link you to all the participant docs. So if you're doing this meeting from your phone, just scan that. It'll take you to the Google Drive space that has everything in it: participant list, agenda, breakout assignments, breakout note-taking documents, everything you need. You'll notice that we're set up on table rounds here. There is a purpose for that. We want to encourage as much interaction as possible. So sit at different tables every day, sit with different people. The workshop was intelligently designed to really enable the kinds of conversations we want to make the science and the observations better in the ocean. So that's really what this setup is about, and we really encourage you to take advantage of that. The panels, you can see a big table up here. It has a big trawl on top of it, but that's for fun. You can see the microphones for the panelists. The panelists, you'll see the names of the panelists. They will all come and sit up here. And whenever they're speaking, they'll speak into the microphone. We will have, in some cases, 1 or 2 remote panelists, so their picture will be up on the screen. And that's how the panels are going to work. So each panelist is going to be given a certain amount of time to say a few words about themselves. Maybe they have a slide or 2 they want to share, and then it will be open Q&A time. The breakouts. So you've all looked in the participant documents folder by now, I hope. In there, you're going to find the breakout assignments for breakouts 1 and 3. Hopefully you have signed up for where you want to be in breakout 2. We may be changing the format of that. We're kind of waiting to see where people's interests lie. So please, if you haven't already gone in and signed up for breakout 2, where you want to be, please do so we can figure out how we want to create that for tomorrow. So that's your assignment for tonight. The tables will be labeled so that you'll see the breakout assignments for today. Breakout 1, each of these tables is going to be labeled. You're going to do the breakouts actually around these tables. So we don't have to travel too far. And there's note-taking documents in the participant docs. If you could check and make sure that if you're a rapporteur that you have access to those. And let's see, the moderators and rapporteurs are assigned. If you have issues with being a rapporteur or a moderator, please see us so that we can get somebody else. For the virtual breakout groups, you're going to assign your own moderator and rapporteur, and May and I will be moderating your groups for you. On Friday morning, the moderators and rapporteurs for each of the breakouts are all going to meet with each other. So all of the breakout 1 leaders are going to go to one place, all the breakout 2 will go to another, and you're going to synthesize 1 or 2 slides a report out for that breakout to the audience. I think that's all I have for that. And then the show and tell, which is going to be tomorrow afternoon, is going to be over in the David Center. So that's the only thing that's not taking place here in Clark 5. You're going to be in the David Center for that. And we will all walk over together as a group. There are campus maps on the website and over there if you need one. We're going to do lightning talk introductions followed by table demonstrations with gear and technology and new data products. So that will be all set up over there for us. And there will be plenty of snacks and beverages and heavy hors d'oeuvres for that as well. So we're going to feed you well. We're going to group you in different ways and try to get you to interact with each other as much as possible and hope for a really great time together. Does anybody have any questions before I hand it over to Alec? Awesome. All right, Alec, you're on.
Yeah, welcome. I'm Alec Wong. I'm a marine chemist on campus here. I'm in the marine chemistry and geochemistry department. So I started 2009, and then been here for the last decade, basically. But this is very exciting to me. So I study ocean carbon cycling. So I'm one of the organizing committee members. So first of all, I'd like to acknowledge my organizing members. So if all of the members can stand up for just brief introduction, be great. So please. So yeah, Jenny, Glenn, a lot of you know them. They're from Uspo. Okay. So and then Jim, Benny, and George from Northeast Fishery Center, Aubrey and Dave from Commercial Fishery Research Foundation, Cooper, Ranton from Ocean Data Network, Aaron, and Huanxin from Gulf of Maine Lobster Foundation. So make sure I encourage you to talk to folks. So we welcome all the comments and critics and suggestions you have. A big thank you to the OCB office, Heather, May, and Mary. I have a little gift for you, so make sure I hand it over later today or tomorrow. So, and a big thank you for Fishers. That's a special, this is a very different workshop I've been to. So I think I really appreciate the Fishers can really contribute this, because this is a central part, a piece of this network, okay? So with that, I want to give a little overview of this workshop. So this is some of the motivation here. The goal, bring together everyone, basically you in the room and everyone online, to make plans to establish a fishery-based biogeochemical observing network. So basically, we're talking about put chemical sensors, biological sensors onto fishing vessels, fishing gear, right? So this is obviously built on the success of decade-long, experience and infrastructure that you guys already involved to deploy physical sensors on fishing vessels, right? So we're going to add new sensor to improve the capability, especially ocean carbon, some of the climate-driven signals. Deliverable for the workshop, we try to kind of determine the scientific scope. So what can be defined or measured by fishing activities and the need from all partners, right? So everyone has equal contribution to this. We want to hear what you need are, okay, and requirements, okay? Then hopefully at the end of the workshop, we can decide some of the next steps and then maybe a roadmap, how we successfully set up this this observing network. We're hoping there's maybe even a white paper come out from the workshop. So I'll encourage you to reach out to me if you're interested to contribute a white paper, okay? So the white paper, the purpose of that is kind of setting, just like the deliverable, we have setting some kind of community goal or scientific goal, and then what may be the concrete steps and roadmap to achieve those. And that could be a peer-reviewed journal. So why we care about the biogeochemical network? So there are many needs. People already know for ocean observing, so from societal fishing activity to scientific research, to forecasting, to project the future change, for example. So to maintain, to establish or maintain a good ocean observing system, it depends on a lot of factors. I list a couple of them. There's many more. One, for example, the cost of maintaining such a network, the robustness, of the technology and platform, the quality of the data, how you maintain the quality useful to all users, how you deliver the message or the data to the community. Those are all how do you maintain it. Okay, those all factors. So I'm studying marine carbon cycle. Okay, so in the middle of the plot, I just show what we currently have. So I'm interested in CO2 fluxes. Carbon dioxide is a very important parameter to determine a lot of things, including climate. How much CO2 in the air versus how much CO2 dissolving into the ocean. So that's very important to me. But look at this is the in situ sensor network on buoys around the United States. So there's a handful of in situ sensors. At the individual site, you can have relatively good temporal coverage, from minutes, hours, month, year, inter-annual, and so on. But there's a lot of holes in between. And then we think that's a big problem for us to project, for example, what may happen to ocean acidification along some of the coast area, because we don't have enough data to say that. Down the right is this is the traditional bottle samples we collected through fishing from the research vessels over 3 decades. Okay, this is Northeast water, and by seasons. So you can see there's a lot of data holes. There's some season maybe better summer, but other seasons there's many unknown area that we didn't sample for carbon parameters. So this is the kind of the starting what do we have. So as a comparison, this is what a weather station in North America. So you can see the coverage of the sites is at least order of magnitude higher than what we have in situ along the coast, right? So they achieve this, one of the main approach they do is they basically adapt this community-based approach. One big reason they can achieve such a coverage is because they develop a low sensor technology. In this case, it's a low-cost weather station. Okay, so you probably can type in some weather station in Amazon.com and then find some low-cost weather station. So if you into this, you can buy it, you can install it, and then the data can be shared and contributed to the big community. And then we all enjoy the weather forecast, much better weather forecast nowadays, compared to in the past. And this is the kind of the model we try to after. And just over the last several decades, the ocean sensing community already developing low-cost sensors. So this is just a review paper we did a couple of years ago. Kind of summarize what do we have at that moment. So one take-home message of this is that we started seeing some of very useful low-cost sensors coming out from the community. For example, dissolved oxygen. I know that people already deploy and there's a commercial available DO sensor and low cost. People can buy it and then can install, for community-based observing network. pH is another parameter, probably in the horizon can measure in coastal water. So this is probably kind of borrowed from EMOT and Shell Fleet research. This is not my work, but this gives you a sense what the fishery-based network can cover. And this is obviously built on the existing physical parameter measurement, measured on fishing vessels. And on the left is you can see the very high density coverage of sites in the Northeast through multiple decades and by various programs. And then down there, you can see the temperature, annual variability of temperature over the 2-decade time. This is often New Hampshire by E-mode program. So this demonstrates that we can really do a lot with fishery-based observation, and then you can see the trend over time, not just the seasonal or annual variability, but also long-term trend like warming in the Northeast. On the right, you can see this the shelf fleet program, the salinity profiles in shelf break area in southeast England. So this is my last slide. So there's many advantages for doing this. The first one, obviously, is much cost effective, right? So this is because we use ship opportunities and low cost sensors. The cost of maintaining such a thing is going to be much smaller than the regular observing network, which costs hundreds of millions of years. I mean, millions of dollars. And because the ships go everywhere, pretty much all the time, and so this can substantially improve the spatial and temporal coverage. There's a lot of co-benefits. The data collected will benefit not just the scientific and forecasting, ocean forecasting, but also fishing operation and resource management, right? So this is enable solution-driven science. For example, the data collected can be used to help a fishing operation. People already know that the temperature may be very important for fish fishing. In this case, maybe the oxygen is also very important. The acidity of the seawater is also important for the fishing operation. This is going to engage user-based citizen science. What we try to do is try to, as I showed, weather stations. This can get us to that stage, right? And the last, I think this is very important. You improve the data equality access. Just to give you an example, in a lot of places, we don't have ocean observing network, okay? So the fishery is, kind of the platform that can have such a network, but without spending too much of resources. I think, in a lot of other areas in the world, this may be the only way to actually achieve a reasonable ocean observing. So that's my introduction, and thank you for coming again. So I'll hand over to Jenny for Plenary. Thank you.
Thanks, Alex, for that fantastic introduction. So my name is Jenny Ruben. I am a research specialist in WHOI's Marine Chemistry and Geochemistry Department, and I'm also affiliated with WHOI Sea Grant, and I'll be moderating our first plenary here today. I'm really excited. We have an awesome lineup of speakers, and who are here to share about their experiences designing and maintaining fishery-based observing programs. So just a couple of quick things. If you have questions and you are a remote participant, please put your questions in the Q&A box in Zoom. We will be monitoring that, and so we'll be able to read out your questions if you have them. And if you're here in the room today and you have questions after the speakers are finished talking today, we're going to bring you a microphone, and so please hold your question until you get the microphone so that our remote participants can hear. So for our speakers, I'm going to be really keeping you on time. So I'm sitting right over here in this table. I will have little cards. I'll give you a 3-minute warning and a 1-minute warning for your sort of 12-ish minute slot. So please, just keep in mind, we want to try to keep on time today. If you are a speaker and you don't mind, just pay attention a little bit to the agenda. We just want to ask that you come up here during the Q&A after each presentation before you, so that we can set you up with a microphone so that our remote participants can hear you. So with that, I will introduce our first speaker here today, who is Trey Chu from the Massachusetts Division of Marine Fisheries.
All right, so did this thing come on? Can you hear me? hi, thank you for inviting me. My name is Trey Chu. I'm with the Massachusetts Division of Marine Fisheries. And I am going to talk today about the Cape Cod Bay Study Fleet and the development of this program, some improvements we've made over the years from things we've learned, and a couple of the challenges that we've encountered along the way. So first off, because I recognize there's maybe some folks not from around here, and this is a very specific talk. So Cape Cod Bay is, you can see where we are at Woods Hole, and Cape Cod Bay is sort of the interior of the arm of the Flex Cape Cod. So that's the region that we're going to be talking about here today. And essentially, this is a very targeted project that started in 2019, when in September, the division started getting some phone calls from lobster fishermen and from the Mass Lobstermen's Association that they were pulling anywhere from a couple dozen to several hundred dead lobsters in their traps in Cape Cod Bay. This is obviously pretty alarming. So we really started trying to figure out what was going on, where is this coming from. So the reports were all sort of targeted around that September 20th to 24th timeline. We were also getting reports of dead crabs and dead fish in the trap, so it wasn't specific to one species. We had reports from a dragger who had a high proportion of dead scallops in his toes. And these were all coming from the southernmost portion of Cape Cod Bay, at water depths around like 30 to 80 feet water depth, which I think is like 9 to 25 meters or so. So we our project sort of dropped everything and tried to figure out what in the world was going on. And with some help from the Center for Coastal Studies, hold on, I'm stuck. There we go. Center for Coastal Studies helped us get out there and do some pretty widespread water quality sampling, and this was sort of how we found the smoking gun. And what we were seeing here is some extremely low dissolved oxygen values, low enough that they are actually severe hypoxia. Hypoxia just meaning there's not enough water, not enough oxygen in the water for animals to breathe. And we were seeing values, if you look at the circle of red dots down there, we're getting values in those red areas from like 2, some less than 1 milligram per liter of dissolved oxygen. Those are definitely lethal to lobsters and other animals if they are stuck in a trap and can't avoid them. It seemed to be very concentrated to just on the bottom, so the upper portion of the water column was totally fine. It was actually loaded with mola molas. It was ridiculous. It was really cool. The hypoxia conditions seemed to last for about a week or so, probably a little bit longer, but based on what we were able to collect and what we were hearing, it was probably about a week or so. So at the end of this, we talked to the fleet, the fishermen who were affected, and they said, what can we do? We're interested in being sure this doesn't happen again, or if we can't fix the problem, what do we do to know that it might happen again? And that was sort of the impetus to got the Cape Cod Bay Study Fleet started. It was very much from the fleet's interest. So the Lobster Foundation of Massachusetts in spring of 2020 were able to get some funding from the Massachusetts Climate Change Resilience in Fisheries and Aquaculture Grant Program, which is a mouthful. It's essentially a legislative program that they had a bundle of money that they were targeting towards climate change related issues. And the Lobster Foundation of Massachusetts got a chunk of that money and were able to invest in the equipment to put on the boats. So we had 25 dissolved oxygen and temperature data loggers. And what we did was we had 5 vessels. So each of the 5 vessels got a deck box and 5 loggers. The loggers record dissolved oxygen and temperature every 15 minutes. You can set that to whatever you want, essentially. And when the logger goes in the lobster trap hits the bottom, the logger is recording continuously. As the fishermen haul the gear, as soon as it comes up and is within range, it downloads the data with the Bluetooth, and then the deck box talks to a server on land. So it's all very hands-off, automatic data collection, which is fabulous. You can see our coverage for 2020 in the bottom left there. So we had the 5 different vessels pretty much spread all over Cape Cod Bay where lobster fishing is occurring. So just a quick look at some of the data. Again, this is continuous data, and with every 15 minutes, it's a lot of data. So you can see here, this is just from one region. This is the Sagamore region, which is, if you know where the Cape Cod Canal is, which is sort of in this area of the arm, just immediately north of the canal entrances where Sagamore Beach is. We had a cluster of loggers there, and this is what they were reporting back for the season in 2020. And when you look at this, you can really see some strong patterns that all 5 of these loggers were detecting. The first, we see this decline from around mid-August through the first half of September in 2020. And then we had this period around mid-September or so where we had the improving conditions. And in this, the blue is the dissolved oxygen, orange is temperature here. Early October, we saw a little bit of a decline again that a couple of the loggers picked up, and then followed by another improvement. And then again, we had this mid to late October, we saw another sort of downward blip, if you will, in dissolved oxygen before it finally improved, and you know, fall storms kind of mixed the water column and mixed this out. So the nice thing about this is we have this continuous high resolution data being recorded and stored. So we don't have to worry about losing sample collection days to bad weather. And the bonus, we actually get to see what the bad weather does to conditions on the bottom, which is in this instance actually really critical. So again, the loggers that are in the lobster pots, they don't require a special trip. There's very little in the way of special equipment that you need. Once they're installed, for the most part, the fishermen don't really have to change their day-to-day behavior. They just go about their day, and the loggers do their thing, and we get the data. The footprint of the fishing fleet and working with multiple different boats lets us get this really nice broad spatial coverage. So we've got high resolution data, continuous data with a really broad spatial coverage, which really lets us take a good look and monitor how conditions are changing over time. And you can see in the graphic here, this is the 2022 season's data. You know, you can see our spatial coverage in the map on the top, and then the dissolved oxygen data coming in on the bottom. And you can see, again, most of the loggers are detecting that seasonal downward trend in dissolved oxygen pretty consistently throughout most of the bay. And then things get interesting. So some of you have heard me talk about this before, have heard me refer to this as the blob, which explains the green image that I like to use to help conceptualize what is going on. And we really use the fleet data in combination with a collaboration with Center for Coastal Studies and with Woods Hole Oceanographic to try to figure out what's driving this condition. So this is new. We'd never seen anything like this in Cape Cod Bay before in terms of this severe hypoxia. So, all right, now we see it, but why? What's going on? So this collaboration in conjunction with the study fleet data really started to let us take a look at what was going on. What we did is we were using the fleet data to essentially monitor how the conditions changed over time. And when we saw something going on, then we would get the research vessels out with the sort of more traditional water column sampling devices to take samples all the way down through the water column. And the first two graphs on the left over here, you can kind of see what a water column profile looks like. So this combination essentially was what was letting us see both the size, the shape, and the location of the blob. And I call it that because it is kind of a relatively cohesive water mass. So it's being compressed down to the bottom. It's below the thermocline or the pycnocline. So it's down in the cold, dense bottom water layer. And that seems to be kind of holding it down there and holding it together to some extent. It does move around. And we think that this is driven by wind-driven upwelling and downwelling events that sort of push this water mass around. And you can see that in the top graph. So the top is from September 10th of 2020. And if you look at the cluster of really warm colors, that's actually the minimal, that's the low DO. And the y-axis, the horizontal there is distance from shore. So this is a transect from roughly Barnstable Harbor due north into the bay. And you can see the 10th, it was right up along the shoreline, about like, you know, a kilometer or so from shore. And then by the next week, it had been pushed off to about 6 kilometers north to 6 kilometers offshore. And again, we think that this is the wind moving it around. One of the other things that we learned here that I don't have time to talk about today, so you'll have to bug me later, is that this low dissolved oxygen does appear to be associated with a subsurface chlorophyll bloom. So we think there's a subsurface algae bloom that might be sort of one of the whys behind why the DO is getting so bad. So we've definitely made some improvements over time. We've been doing this for 3 years now. In 2020, our original plan for actually handling all of these data coming in didn't work. So we ended up doing a lot of the visualization and the data processing kind of manually. I don't recommend that. It was miserable. By 2021, we finally had our act together, and we had a GIS application with some coding running in the background that automated the process. So the processing of the data, getting rid of some, oddballs, and then actually averaging it over 6-hour intervals, made life much easier, visualized it for us so that we could track it, and then the development of this dashboard app, which is what you're looking at here. That's how I actually look at it at my desk to see what's going on in terms of changing conditions. So this was key. And then in 2022, we finally were able to get a publicly accessible website up and running so that anybody who's interested in seeing what the conditions are can get on this website. It's mass.gov/Cape Cod Bay DO. So they got us a nice, easily memorable, tiny URL. And you can go here. There's some very basic information about what hypoxia is, what causes dissolved oxygen to go down. And then the public can get on the map and see, and if you look in the upper left, you can look at it for the past 7 days, for the past 2 weeks, or for the whole season. So this is the 2022 season, the whole season. All right, so in this process, we also encountered some challenges. The first one I've already talked about is there's a lot of data coming in. If you've got your loggers logging it like every 10 or 15 minutes, one logger was taking over 17,000 data points in a season. We had 25 of them out, sometimes 30. It's a lot of data. You don't want to deal with that manually. So getting that automated process was really key. Sorry. Where's my button? There it is. I need it again. All right. So interpreting the data. This is one of the this is the fun part. Kind of important to be able to interpret your data, but it's actually kind of challenging because I told you that the blob moves. So the weather patterns, wind patterns are moving the blob. So when we get a graphic that looks like this, we see this decline, a pretty steep decline in, when is that? September. So you see that steep decline in December, and then all of a sudden it shoots way up. Conditions improve really quickly. I look at that and I'm like, oh, they moved the gear. They moved the sensor. But if you look, the 4 thick points in the graphic are actually what's plotted in the map up there. That sensor did not move. That's the blob probably shifting away from that particular sensor. When in another instance, hang on, sorry, wait for it. There we go. Earlier in the season, we see the decline, and then again, that immediate jump up in conditions. And in this case, it actually was the sensor moving. You can see in the map up there. It didn't move a lot, but it moved just enough. And maybe that was a depth change that got it just out of range of where the blob was sitting. So interpreting the data can be a little bit of a challenge here. And this moving of the sensors is a normal part of pot gear fishing. The fishermen are moving their gear to keep their catch rates up. So that's just sort of a part of the, it goes with them. It just goes with it. It's something that we have to figure out how to deal with. So the lat long and being able to visualize is key to interpretation here. From a DMF perspective, trying to figure out when do we issue alerts to the public in terms of we're starting to see conditions, we think it's going to get hypoxic. And then do we even try to issue an all clear? With the data interpretation challenges and with the changing seasonal patterns, it's really tough for us as a division to decide whether or not we're going to commit to telling the public everything's fine, because if we're wrong, it won't go over well. So that's one of the challenges as an agency that we're still trying to figure out how to deal with. And finally, this is something I imagine is going to come up frequently today, long-term funding for this. Obviously, there's annual maintenance. If you lose the gear in a storm, you have to deal with replacements, and then any kind of compensations to the vessels. So there are some long-term funding questions that need to be sort of, we got to figure out how to deal with that. So I just want to very quickly thank the initial Cape Cod Bay study fleet. These 5 guys were crucial to getting this whole program started. They were the first 5 participants. And if you want to hear more about the hypoxia in Cape Cod Bay in terms of what we learned about it, Malcolm Scully led a publication that sort of summarizes what we think we know, and there's stuff available online. So thank you, and if I haven't totally blown through my time, I can take questions.
Yeah, thank you, Tracy. We have time for a couple of questions, if there are any.
Thank you, Tracy, for that. I'm Liz Perotti from NOAA's Ocean Acidification Program. And I wanted to hear either from you or from others in the audience if you've had feedback from the fleet in continuing this and some of the incentives or what the utility they've found with this application now that you have a website up and running. Thanks.
Yep. Yeah, so we actually were invited to the Mass Lobstermen's Association's delegates meeting this past fall, where we sort of gave them a little bit of a presentation about what DMF thinks about the utility of the program. And we heard back from the delegates that they definitely want to continue this, and they actually have interest in expanding it to other areas along the coast. So they are interested in it. In terms of how they're using it, that's actually a really good question, and I don't know yet. I'm hoping that they're starting to go to that publicly accessible website. The website shows both the DO values and the temperature values that are coming in from these loggers, so you can toggle in between the two data sets if you want. I certainly, being a lobster biologist, I'm really interested in what catch might look like given the temperatures around. And then also, you know, the DO aspect of it and how does the catch relate to that? So we think that DO, the lobsters are going to detect it and they're going to try to avoid it. So we think that there might be a little bit of like herding effects. So I'm hoping that the fleet looks at the data that are coming in and tries to use that. And then obviously if we start seeing it really go down, our hope is that they're going to see that and they're going to want to get their gear out of the way, or at least haul it more frequently so that the lobsters aren't stuck in the pots and exposed to being, you know, suffocated essentially.
Great. Thank you, Tracy. So I'm thrilled to introduce our next speaker. This is Aubrey Ellerton from the Commercial Fisheries Research Foundation.
Awesome. Thank you. Hi, everyone. Good morning. For those of you that aren't familiar with the Commercial Fisheries Research Foundation, we're based in Rhode Island, and we're a nonprofit private research foundation that was founded by and continues to be directed by commercial fishermen. And so today I'll be talking about our lobster and Jonah Crab research fleet. All right, so just to give a little bit of background, American lobster is one of the most valuable fisheries along the East Coast, producing over $620 million annually and supporting thousands of fishing families and coastal communities. It's broken down into two stock units, the Gulf of Maine Georges Banks stock in blue and Southern New England in red. As you can see, the Gulf of Maine Georges Banks stock has rapidly increased since the 1970s and accelerated pace since 2007. Whereas Southern New England had a peak in the 1990s, followed by rapid declines in the 2000s to a record low in 2013. So it has a very different trajectory, and many lobstermen in Southern New England in particular have turned to another species to support their fishing businesses, and that is Jonah Crab. Jonah Crab is a distant cousin of Dungeness crab. It's known for its sweet and tender meat and large claws. The annual landings in 1990 were about 1 million pounds and jumped to about 16 million pounds in 2019. In 2021, the U.S. landings were 11 million pounds. So this has really allowed lobstermen to diversify and reduce their dependence on lobstering and has allowed for supplemental income. Many of the fishermen that we work with came to the Research Foundation initially in 2012 to discuss some priorities that they wanted to do to create a research fleet to improve the science and management of the stock assessments, as well as to expand both biological and fishery data sources beyond state and federal surveys. Oftentimes, state and federal surveys may only go within 3 miles or a few times a year, and so fishermen really wanted to be able to collect from areas and times of year that were not traditionally sampled, and then improve credibility and trust in research fishermen as research partners, so including them and recognizing that industry-collected data is science. So to get going, we started the research fleet in 2013, and something that I find really unique about the Research Foundation is the way that we start and develop a project. So from the very get-go, we have a steering committee comprised of scientists, managers, and members of the fishing community to guide sampling protocols. So we want to make sure that the data we collect will be easily incorporated into stock assessments and management plans, but not burden fishermen's time on the water. So this is a really great point at the conceptual stage of a project to make sure that everyone's voices are heard and that the data will be used. Next, in practice, fishermen are out on the water and they collect biological and environmental data at sea. We give them specialized tablets and digital calipers, as well as temperature sensors. So when they're out in their normal fishing day-to-day operations, we ask that they collect and sample a subset of their catch. When they are back to port and are connected to the internet, they upload that data to us near real time. And myself and other staff will audit the project database and make sure that the data is good before we send it to end users. Something that's unique about our program compared to a lot of others in the Northeast is that fishermen always have access and ownership of the data that they collect. So every 3 months, we send them copies of their raw electronic data, as well as any temperature time series that they're interested in. And this has a lot of really important data impacts. Not only do we do recent publications on updated lobster maturity or our data approach, but also it improves stock assessments and management plans. Our data has been used in the 2020 and 2022 benchmark lobster stock assessment. It was also instrumental in the development of the 2015 Interstate Fishery Management Plan for Jonah Crab and for the upcoming first ever Jonah Crab assessment scheduled for 2023. And it also fills data gaps offshore, which you can see in those red stat areas that were previously not sampled or had very few samples and are now robustly sampled by our research fleet. But this process isn't just continuous, it's continually evolving. We're getting new technology, new apps, new Android operating systems. We've adjusted our Ondeck data app, which is our biological sampling screen, to have egg staging. So many stock assessment scientists have wanted to learn more about that. So now fishermen can select an image from that screen as an opportunity to see what they see on the water. And then our data is shared with the Atlantic Coastal Cooperative Statistics Program, which is the primary data repository. So to date, we've had 34 different participant vessels. They've sampled close to 195,000 lobsters and over 115,000 Jonah crabs. We developed an app called Ondeck Data, and so it automatically grabs the date and location, and fishermen enter the depth, soak time, and number of traps sampled. And then they have a variety of different biological parameters. So this is what our app looks like. On the left-hand side is our lobster commercial sampling screen, and on the right is our Jonah crab. So they do sex, size, presence or absence of eggs, whether it's kept or discarded, shell disease condition, molt stage, et cetera. So this is a breadth of knowledge. We have a ton of data, and we want to be able to continue to not only help support management, but also tie it to biological and environmental data. So this is just some examples of the data that we show at some fleet meetings with our fishermen. So this is PSI Spectra from male and female from inshore and offshore, lobster management area 2 and 3. And again, this is just the coverage of our research fleet and just highlighting some of those areas that we've now robustly covered that were previously undersampled. And this is just a quote from the 2018 Addendum 26. And of course, that's kind of old now that we're in 2023, but the idea that over 3 million pounds of lobster landings would be completely uncharacterized without our fleet. We've had a tremendous amount of success and knowledge that's been shared both between scientists and fishermen. Another part of our research fleet is our bottom water temperature monitoring. So we use a Vemco Mini Log 2, and it records temperature every 10 minutes. We have geographical range from the Gulf of Maine to Hudson Canyon. It's collected year-round, and we have just over 4.7 million temperature records. So in process, fishermen will zip tie the Vemco logger to their ventless trap. Once the gear is hauled on board, they take the trap out of, they take the logger out of the trap, and they put it in something called a field reader. It's that blue and white box, and it offloads the data right into that field reader. Then they can put the logger right back in their trap and continue fishing. And then whenever they're ready, they'll turn on the tablet and it will wirelessly talk to that field reader and then acquire this temperature time series that fishermen get to see out on the water. This is an example from my house, so 83 degrees, I guess, at one point. But that's just an example of the screen that fishermen will get to see. And then when they're back at port and connected to the internet, they upload that data to us. Here's an example of a temperature time series from one of our research fleet participants. It goes from 2014 through 2021. Average daily temperature is on the y-axis and months are on the x. And really what I'm just trying to show is the year-to-year variability. And it also allows us to really understand some oceanographic events. So for example, in 2021, this fleet participant witnessed a 10-degree change in a week and sustained temperatures over 60 degrees for 6 days. Talking to oceanographers in the room, Glenn Gorkowitz and others, we realized that what was happening was there was a salinity maximum intrusion and the shelf break went well inshore of the 95-meter isobath. And we have very salty, greater than 34.5 PSU. So this is just an opportunity where fishermen are out on the water day to day and are witnessing these changes that we might miss from a federal survey that only goes a few times a year. Also, our 9-year time series has allowed us to do a lot of extension work. I won't go into all of it today, but we've done updated work on lobster maturity, establishing a baseline for the National Marine Monument, vessel effects and spatial distribution, shell disease. But we've also been working with folks at the Northeast Fisheries Science Center to clean up our temperature data. And so on the left-hand screen is our ERDAP, and this is a publicly available data website that houses our temperature data. And you'll be able to kind of sort by vessel or by date. And then on the right is just kind of an instance of the type of challenges with bottom water temperature. Those blue spikes are when the gear is being hauled on board. And so we need to be able to clean those out so that we have a smooth line, like the orange, of really what's been happening at the bottom and what these bottom-dwelling organisms are being subjected to. We're also starting to do some more in-house analyses. So we're starting to work to match all that biological data that we have, this wealth of knowledge, with our temperature monitoring locations. So these are examples of certain vessels. And in white is the biological sessions, and in red is temperature. And so just trying to match those different areas so that we can kind of understand some of these research questions, such as, is there a relationship between lobster and Jonah crab catch and bottom water temperature? What about shell disease, the catch of egg-bearing lobsters? Trying to understand molting, egg-bearing extrusion, growth, any impacts that might have for lobster and for Jonah crab, because there's a lot we don't know about Jonah crab. Some of the challenges are keeping up with advancements in technology. Our current temperature logger is discontinued, the Vemco Mini Logger 2, so we're looking into new loggers. We're really excited to be here today and learn about all the different probes that are available. Also, updates to Android operating systems has sometimes caused some challenges with our apps that we've developed and just making sure that we stay current. Some of our vessel participants overlap with other existing temperature monitoring programs, and while that's not really a challenge, it's just working together and not duplicating efforts. In-person support can be time-consuming and labor-intensive, going to the docks a lot or just trying to catch boats when they're in. Developing certain data QA/QC procedures to clean that temperature data, because as I said, we have 4.7 million temperature records, it's a lot of data to clean up. Securing year-over-year funding, we do provide stipends to our vessels, and so we want to make sure that we continue to have that funds to collect this data and keep this time series going. And also captain and crew turnover, training new fishermen so that they're aware of the sampling protocols, and new area closures. So recently in the South Island restricted area for North Atlantic right whale, it's now removing some of our fleet participants from fishing in an area due to pot trap fishing gear and exemption. So that's going to be an area now where we're going to miss valuable biological and temperature data because fishermen will be out of that area. Our success, so as I mentioned, we have a 9-year time series. It's really allowed for a lot of different extension work and really diving deep into the data. Fishermen are able to contribute to the sustainable management of their resources and have their voices heard throughout the process. They're also able to refine their fishing practices based on what they're seeing out on the water. And then scientists are able to access real-time data when they normally wouldn't otherwise, especially during COVID. This is kind of a shining beacon of hope, working with the fishing industry and continually getting this data. So in conclusion, collaborative research is mutually beneficial. It builds a community based on trust, transparency, and respect. It's a value to have an exchange of information and learn from one another. And I think that that's what I hope that fisheries management will continue to push for moving forward. I'd like to thank all of our fishermen who are involved in our research fleet and our collaborators. And I'll take any questions.
Thank you, Aubrey. We have time for 2 questions, if there are any.
Hello. Thanks. That was a great presentation. I'm from the Gulf of Mexico, so this is very different for me. I'm curious to what extent, like, the environmental information is being included in stock assessments, or is that something that's down the pipeline, or?
Oh, that's a great point. There's been a tremendous effort lately to really work at incorporating that into stock assessments. I think we're working towards ecosystem-based fisheries management and a more holistic approach towards incorporating and understanding predator-prey dynamics and changing ocean ecosystems and what that might mean for distribution of different species. So I think there is efforts underway, but I think a lot of it right now is just combing through the volumes of temperature data, getting it clean, and then being able to use it. And so we've been working a lot with folks at the Science Center, and our data, we try to share with other oceanographers to improve oceanographic models, but if we have this data, we want everyone to be able to use it. So that's a great question.
All right. Thank you. If there are no other questions, thank you, Aubrey. Excited to introduce our next speaker here today. This is going to be Noelle Olson, also from the Commercial Fisheries Research Foundation. Thank you, Noelle.
Thanks. All right, can everyone hear me? All right. Thank you everyone for having me. I'm going to be talking about the CFRF Hui Shelf Research Fleet, some of the successes and lessons learned over the time. I want to thank my co-authors and then the collaborators and people who've worked on this project before I started at CFRF.
So it formed back in 2014 with the goal of studying changes in ocean conditions like salinity and temperature to better understand shelf break exchange processes and their impacts on important fishery resources in southern New England. Currently, we have 3 active vessels. We train fishermen to conduct oceanographic measurements while they're out commercially fishing. Over the years, we've had 17 vessels participate in this project. And I just wanted to highlight that communication between the scientists, the fishing industry, and the public has always been a really important part of this project, which I think has led to the successes of it. So some motivation for wanting to monitor these ocean conditions, the year 2012 was the warmest year in the Northeast U.S. continental shelf region. The video on the left is showing the sea surface temperature from 2012 compared to the average of the 20 years prior. So you can see there's a lot of red moving in, a lot of warm water, a lot more variability. So there have been unprecedented changes in both temperature and salinity, both seasonally and year to year. And as many of you know, both the commercial and recreational fishing industries are extremely valuable in New England. So why partner with industry? It strengthens the science. It's been able to provide a cost-effective way to collect this oceanographic data. Typically, chartering the Hui research vessels is extremely expensive. And so this is able to provide very valuable data at a much lower cost. As many of you know, fishermen can provide an in-depth wealth of knowledge about local water and weather conditions. They're sort of like personal almanacs for their areas that they fish. They're very attuned to the species that they catch. So they're able to know when things are different. And, you know, they're able to make these connections that science and management are really interested in. And Aubrey touched on this, but collaborative research can be highly mutually beneficial when there's trust involved. You need to have participation from scientists and industry to make these kind of projects work. So the structure of how the shelf fleet works, as I mentioned, we train fishermen to use CTDs, which are conductivity, temperature, and depth instruments. So they measure salinity and temperature at depth. You drop it in the water, you create this vertical profile of the water column. And so the captains or crew member will cast the CTD overboard while they're out fishing, generally a couple times a month, and everyone is assigned different fishing areas. The CTDs have Bluetooth capabilities, so when the equipment runs smoothly, the fishermen can actually see the profiles when the CTD comes back on the boat. And then fishermen are able to use this knowledge and inform their own fishing practices. Once the tablet is brought back into cell service range or Wi-Fi range, the profiles are actually uploaded automatically using Wi-Fi. We have a Dropbox folder that all the profiles go into. We do an initial QA/QC at CFRS. The fishermen do receive a modest stipend for sampling, and then I send the profiles over to Frank Barr from Hui, where he cleans, processes the data, and then posts them on a public website. So this is our sampling area, the continental shelf and slope region in southern New England. We have these roughly 6 fishing zones that fishermen fish in specific areas. As you can see, effort is distributed, or it's concentrated in certain areas. That's where the fishing effort is. And I just want to point out that in zones 5 and 6, at the bottom, there's these green boxes. And that's where the Ocean Observatories Institute Coastal Pioneer Array has been since 2013, which is a system of moorings, gliders, and autonomous underwater vehicles. Unfortunately, the Pioneer Array is moving south to the Mid-Atlantic Bight next year, and so we're going to be losing that important supply of data that we've been able to combine the Shelf Fleet data and the Pioneer Array data over the past couple of years. As I mentioned, Frank Barr maintains this publicly available website. Feel free to ask me if you want to check it out later. And since 2014, we have over 800 validated CTD profiles provided from the fleet. There have been more, but unfortunately, sometimes we lose the GPS location from the profiles and we can't include it in this map. This is just an example of some of the data you can see online. It's an overview of the temperature. So starting at the top, zone 1, that's closer inshore, moving offshore. We got temperature on the right column and then time on the bottom. And being able to see these like longer time series, you can see these bigger scale trends. And so Aubrey mentioned June 2021 as being very warm, very salty. This is the same type of figure, but instead of temperature, it's with salinity. So as you can see, we're able to map out where these salinity and warm waters are going over time. All right, so the equipment that we use, we've been using RBR Concerto CTDs. Some of the pros, it's just a simple twist on and off for sampling. It does vibrate. It makes 2 different noises when you have the sampling mode turned on versus when you turn it back off. And as I mentioned, it has Bluetooth capabilities, so you can connect to a tablet or a smartphone. Some of the cons is that weathered commercial fishing hands might not be able to feel the vibration, or if you're wearing gloves, or you might miss a sound if there's a hauler running. So one fleet member suggested that maybe having like a light as like a backup indicator of if it's sampling or not could be helpful. Alternatively, you could have your phone or your tablet out to see if a profile actually got recorded with the cast, but then that requires an extra set of hands. It can add some time. So we supplied the fishermen also with iPads, which we have learned over time is kind of, well, calm down the next slide. Some pros, the Reskin app is free to download and it works pretty well on Apple and Android phones and devices. Like I mentioned, you can see the CTD profile if there's the Bluetooth capabilities and the tablet's running well. And like I mentioned, you can see the screenshot of how simple it is to add a Dropbox account. And then there is an ability to tag the GPS locations of these casts when you're out sampling. Some of the cons, I don't know if anyone has an iPhone, but iCloud passwords systems has become a pain over the years. We kind of maybe lost some of the passwords to the tablets over time, so we haven't been able to update the Reskin app. I think this has been causing a lot of connection issues between the CTD and the iPad, a lot of frustration for the fleet participants. There's like constant pop-ups asking for that password that we don't have. Drink Bar checked out the data. He says it's about a 6% loss of GPS locations for the profiles. General challenges that we've encountered over time, multiple people have mentioned long-term funding. A lot of federal grant agencies only fund projects for 2 years, but we want to be able to have that continuous time series to see trends over time. We did have some disruptions during COVID. We weren't able to meet in person, get those public meetings happening. As mentioned, time equals money. So if the equipment isn't working, the fishermen aren't going to be using it. And we would like to have a more formal way to document biological observations, like, hey, I'm seeing tuna here where I haven't seen them before, et cetera. And then data gaps due to weather, boat area closures, boat maintenance, and location of fishing. All right, I'm going to skip these slides, running out of time. Some oceanographic concepts that I will briefly mention. All right, so some successes from the project. Over time, we have had these really great public meetings where there's a lot of engagement between the fishermen, not just in the fleet, but outside the fleet, where the scientists are able to learn what's happening on the water. The Shell fleet data has been pretty critical in providing linkages between basic and applied research. Some of the topics that people have published on using Shell fleet data to support the findings about marine heat waves, shelf break exchange processes, warm core rings, and salinity maximum intrusions. Although we had some disruptions from COVID, the fishermen were still out on the water sampling, providing really critical data when there weren't any federal surveys going out. Some of the Shell fleet data has been used to support naval acoustic research.
The project team as a whole and other collaborators were able to get funding from National Science Foundation to support 2 process-oriented research cruises to actually map desalination maximum intrusions in like a very fine scale. And then on the second cruise, the Northeast Fisheries Science Center Cooperative Research Branch supported a research cruise, so we went out on a squid trawler and actually trawled in and around a salinity max, which is cool. Oh, I don't know. Oh yeah, there's video. That's on the conveyor belt on the squid boat, the Durston. Some of the other successes related to the shelf fleet data we've gotten has supported the ILEX working group. We're really interested in the connections between squid and these salinity maximum intrusions and warm core rings. We've had a lot of web stories and local news stories about the shell fleet, which I think is really good to engage the public. And then the actual CTDs that we've used for the shell fleet have been applied to the wind farm surveys that CFRF has been involved with. We use just the newer version of that CTD. Some future work, hopefully from this workshop, we'll get some insight on new CTDs or new CTD sensors we can add to create a more robust data set from the shell fleet. You know, we'd like to, you know, we're always open to having more participants as funding comes in, get some new tablets to solve some of those frustration issues. We're looking, our WHOI partners are looking to have a smaller observation system in place since the Pioneer Ray is leaving. And people from the cruises are still working up the data. So we're excited to see that in the future. And we'd like to continue monitoring how the commercially important species are changing in the area. So lots of people to thank, and I'll take any questions.
Great, thank you, Noelle. We have time for some questions.
Hi, Liz Parati from the NOAA Ocean Acidification Program again. Thank you for your talk. Do you see these tools as something that's supporting fishermen decision-making, or is that more like turning the headlights on a car to kind of better predict what's coming next?
I think we do have some fleet participants here if you want to kind of ask them more directly, but people have been able to see, you know, like one of the NPR had, Rob Walsh was noticing there's like dolphins in the area, the water had been warm, and he, you know, kind of helped him decide like, hey, maybe I should just like pause fishing for now, take my boat out for maintenance, and then get back in the water when the water conditions are better. But I think it's both kind of individually on a ship basis, but also, you know, we'd like to have more broader implications for different resources.
Okay, any other questions for Noelle? All right, oh, one more question. Okay.
Hi, Noelle. I'm Jim Moore, Alaska Trollers Association. Recently, we entered a partnership with University of Alaska at Fairbanks to do some sampling, CTD sampling, and we're using the Ruskin, the RVR Concerto also. Mm-hmm. Some of the instruments are equipped with a fluorometer. That's one way you can tell it's on if you can't feel it vibrate. But anyway, I appreciated hearing your presentation and look forward to talking with you a little bit later. One question, do you compensate your participants? Could you tell me a little bit about that?
Yeah, so it's roughly, if you do 3 to 4 profiles a month, I think it's about $350. So, you know, it's not to totally replace fishing effort, but just to show our appreciation and hopefully, you know, get maybe the younger crew excited about doing collaborative research. You know, some of the captains, you know, if they have their crew do the actual sampling, they might get that stipend themselves, you know. Yeah. Thank you.
Okay, fantastic. Thank you, Noelle.
Yeah.
So our next speaker here today is George Maynard, and he's going to be, he's here from the Northeast Fisheries Science Center.
All right. Hi, everybody. I'm George. I'm in the process of sort of taking over the reins of the EMO program from Jim Manning, who recently retired. So the bulk of the work that's going to be shown up here today was accomplished by Jim and my other co-authors, Aaron Pelletier and Wan-Shin Chu from the Gulf of Maine Lobster Foundation. I'll start off with sort of a NASCAR slide here. The Gulf of Maine Lobster Foundation is sort of the core partner for EMALT with us at the Science Center, but we have a lot of groups that we partner with around the region, both in the commercial fishing industry as well as in sort of the technology space and some other science-based nonprofits. So we get support from CFRF, who you've heard from a lot today, as well as the Center for Coastal Studies for sort of on the dock troubleshooting and keeping vessels up and running. We have great collaborators at Lowell Instruments and Ocean Data Networks on the technology side, helping us with hardware and software development. And then, of course, support from all of the industry associations that connect us with their members and help get the word out about this work. Of course, all of that whole team can't accomplish much without our critical partners in the field, the captains themselves, many of whom you see up here are in the room today, and then dozens more who couldn't fit on the slide or too shy to have their pictures taken. So I'll give you a brief bridge history of the EMALT program. I'm not going to dive too deep into the technology that's used because Jim will talk about that more tomorrow. And I won't get too in the weeds with data management either, because I think we'll talk about that in a couple days. So EMALT started out as a very, in a sort of non-real-time mode, where Jim would mail out loggers to fishermen. They'd install them in their lobster traps at the beginning of the season, and then at the end of the season, they'd pull them out, cut the logger free, mail it back to Jim so he could download it and plot it up. This type of work, you can see different oceanographic conditions occurring at different time scales on sort of a daily scale up at the top. A plot from Mark Palumbo back in the mid-90s showing tidal variability as well as the presence of a hurricane later in the time series. From Bob Colbert, some Gulf Stream ring variability at more of a weekly scale there, and then seasonal variability from Bro Cody in 1997. By 2011, the EMALT program had grown to 194 sites across the region through the cooperation with a bunch of different lobstermen's associations. So down east, Maine, Massachusetts, the Atlantic Offshore Lobstermen's Association. Whoops, don't know what that is. 2 seconds, no. I think we got it. We also, Jim was also working with the Fishermen and Scientists Research Society up in Canada at that time. Currently, this non-real-time mode of EMALT, where the loggers are mailed out every year and then mailed back, has kind of shrunk as a part of the program. There's currently 29 active sites, so it's with 24 participating vessels. You can see those sites in red, and then the historic sites in black. So all told, there's 505 sites that have been monitored using this program. But critically, the histogram there at the bottom shows the number of years that sites have been active for. So again, the historic ones are in gray, and then the active ones are in red. All right, move this out of the way. And those red sites, you can see folks who are invested in this program who've been active for a long time are the ones who are driving the current data collection. So a lot of those active sites now have several decades worth of data. And here you can see plots from a few different sites. On the right-hand side of the screen, you see a 20-year yearly annual average temperature bottom temperature at different sites. Sort of across the board, we see that 0.18 degrees Fahrenheit or 0.1 degrees C rise over that time. And then over on the left-hand side, you can see sort of variability from year to year at a single site off of the mid-coast in Maine. And that site in particular had both surface and bottom temperature available. Obviously, there's a lot of use for those long-term data sets and sort of fine-tuning, retrospectively fine-tuning models. But there's not a lot of utility for forecasting because you need data more quickly than the U.S. Postal Service can provide it. And so that's where Jim and the Gulf of Maine Lobster Foundation started to switch towards a real-time approach in 2015. And like I said, I'm not going into the technology too much today. There's a bunch of variations on what an EMALT system looks like on a boat, but there's three basic pieces of hardware in all of our systems. That's a probe, a deck box that communicates with the probe, and then a transmitter to push the data from the deck box back to shore. The basic way the program, the real-time program operates, you put a sensor onto the gear, and then when the gear is hauled back, it communicates via Bluetooth back to the deck box that's usually set up in the wheelhouse. The captain can see a display if all goes well. They see the display in real time along with the 30-year climatology for that area that they're fishing. And then the data are offloaded back to us, back to our servers. Currently, we have about 75 vessels participating in this program, and over 22,000 haul average records since the start of the real-time effort in 2015. You can see the pretty quick ramp up, the number of hauls that were recorded in this program from 2015 to 2019, 2020. But we may have hit carrying capacity at this point. There is one dedicated staff member at the Northeast Fisheries Science Center for this program, that's me. We have one dedicated staff member at the Gulf of Maine Lobster Foundation, that's Won Shin. And everybody else who participates is sort of engaged with the project as a piece of their other responsibilities. And so it's becoming logistically challenging to add vessels to the program. Here you can see sort of the spatial coverage of EMALT with the newest data in the brightest red color from 2022 and 2023. The dark colors are dark red 2021, and then the pink circles are 2020. So you can see we've got really good coverage here in southern New England, down into the mid-Atlantic, some on Georges Bank, but we're missing, there's a conspicuous hole for the western Gulf of Maine. So just really quick, I'll walk through some of our current efforts and our next steps. Just a quick plot of what is happening on the water now. We're receiving two different kinds of data from the vessels. Blue is our environmental data, so that's your average temperature at a specific location. And then the red are status reports. So we get these pings when a vessel has a system that's powered on, but they're not connected to a probe. So these basically tell us, yes, the system is functioning and the satellite link is working correctly. And we're working on adding other information into those status reports, things like system uptime, when was the last time it connected to a logger, how many GPS satellites can it see, that kind of information that will help us from sort of a program management and logistics point of view. We're also in the process of developing a database alongside our colleagues at the Ocean Data Networks that will store not only the real-time environmental data from the program, so these haul averages, but also the raw data when that comes back, and then the real-time status reports, and alongside all of the deployments of sensors and satellite transmitters, so you know which piece of gear is on which vessel at which time. And more importantly, or also importantly, you know what software or firmware is installed on that hardware. Because all of this kind of information down at the bottom, while it's not the scientific information that's exciting to look at, it's really important from a troubleshooting and program management point of view, just to know how well your system is functioning. To facilitate all of that, we've been developing an API in Plumber. That's a R package. But basically, it'll allow vessels to send data directly or send data to the API where it can be pushed out to our MySQL database. And then that MySQL database can use the API to talk with or to serve the data in ways that are useful to different end users. So, for example, a technician in the field could hit the API to get information about which sensors should be on the boat, or what the MAC address of a particular sensor is. The oceanography folks can pull data, can contact Plumber to pull data from the SQL through ERDAP. And then a fisherman could access a web portal that's currently being developed by Ocean Data Networks that sits on top of the API and communicates back to the database. So the fishermen can see data that are important to them. But we can, by having this sort of translation layer in the middle, we can deliver data in a lot of different formats. We've faced a number of challenges over the course of just my year and a half with this program. In-person vessel support is required for a lot of these vessels, and is valuable because then you get to talk with the captains and sort of understand how they're interacting with the system and what their suggested improvements might be. But it's also very time consuming, to travel around the region. We've got vessels operating from the mid-coast all the way down to New Jersey. And Wang-Shin and I both live here on the Cape. So it's a pretty wide area to cover. Also, the troubleshooting can be tricky without that performance data that we talked about earlier. So when you go to one of these vessels in a far-flung port, you got to bring everything with you just in case you don't necessarily know which piece of hardware has failed. Did the vessel stop reporting because the captain turned off the unit? Is something unplugged? Sort of understanding that will be helpful. We also have trouble keeping everything sort of on the same software version or firmware version. So hopefully having better network access in ports, Wi-Fi or cell phone network will alleviate some of those concerns. Although it's not a panacea, you can see here the Mary Elizabeth off to the right is one of our participants in Situate, and they have great service at high tide and no service at low tide. I'm really excited to be here today because I think, as folks have talked about, there's the need to QA/QC this data, and the need to experiment with different types of sensors to understand what the best options might be. And so I'm really excited to be in the room with a lot of smart people and learn from all of you, so that we can all stop reinventing all of these wheels and push forward together. I'll just close with a quote from Jim and say that we at the EMAL program, we really believe that science is a team sport, and just very excited to be here today. So that will take any questions.
Thank you, George. We have time for some questions.
Thank you, George. Wonderful talk. Just briefly, you said the real-time data. So my understanding is the sensor stay in the water for the deployment, but can you give me a sense how much time it stay in the water versus being transmitted back to land?
So that all depends on the gear type. We have some offshore lobster boats where the gear might be, the sensors might be in the water for 14 days, 12 days, 14 days. Then there are clam dredgers where the tows might be as short as 5 or 10 minutes. And so once the gear comes out of the water, though, the latency is under 20 minutes until it's available in sort of our real-time data products.
Sorry, one more. So we talk about the usage of data. So in your case, how the fishers use the temperature data you collected? I mean, do you have some example of that?
I would defer to any of the numerous email participants in the room to talk about their experiences, because I think it varies based on the fishery that folks are active in.
Thank you, George.
Yep.
Great, thank you very much. So our final speaker this morning is going to be Linus Stoltz, who is here from Oregon State University.
Hi, everyone. Super excited to be here. I'm going to get to talk to you guys about some work that I did, partly for my master's, but I'm still doing it, been administering this cooperative research project in Oregon for the last 3 years. We've been partnering with Dungeness crab fishermen, not all commercial, mostly commercial. We've got a few charter fishermen, and we're starting to branch out and get connected with some tribal folks up in Washington to study dissolved oxygen. And before I talk about what we have been doing and how we've been doing it, I always like to start with why, once the computer's working, and there's some links to our data and our website, and those will be up at the later in the talk too, if you want to check that out. Here we go. So why are we collecting dissolved oxygen measurements in Oregon? You've heard about hypoxia here in Cape Cod. It's a growing problem, but it has been a problem for us in Oregon and the Pacific Northwest really for the last 20 years. They started noticing dead crabs being pulled up in crab pots about 20 years ago. And this wasn't an isolated issue. This has happened again and again. And there are no shortage of reports that crabs are dead. It seems like it comes in waves. It's not always consistent. But we do know now that there's almost a season for it. So we see seasonally hypoxia every year since the last 20 or so years. This is a problem with Dungeness crab fishery. If you've ever been to Oregon, you know that crab is king on the Oregon coast. It's very valuable. And so these hypoxic events are a challenge, not just for fishermen and for the health of the stock, but also fisheries management. They've got the International Halibut Commission that does ground fish surveys. And they're noticing that, oh, look, when we see hypoxia, we're not able to detect other ground fish species. So it's really messing with our ability to monitor other stocks and other resources. So that's a challenge for fisheries managers and for fishermen. So just a little bit about the oceanography. I won't get too much in the details, but we know really what causes this. It's wind-driven upwelling. So seasonally, we have upwelling and downwelling regimes on the West Coast. So summertime winds from the north will blow north to south down our coastline, and we'll see the transport of surface waters offshore, and that water gets replaced. It's not just empty beach, it gets replaced with water that's deep past the continental shelf. In Oregon, if you're not familiar kind of with the bathymetry, it gets deep really fast. We only have to go 10 miles and we're in 300 feet of water. So it's nice that people can be close to shore for that. But so that the water that comes up off the shelf is inherently low in dissolved oxygen. So that's the physical mixing component that's driving oxygen down, but also that low oxygen water the source water that comes up from the depths is really high in nutrients. So that fuels massive phytoplankton blooms. That's part of the reason why we have such productive fisheries on the West Coast. So it's good, but too much of a good thing is bad. So we're seeing more intense upwelling, more intense phytoplankton blooms, and so that's that physical mixing, and then the biological drawdown when the phytoplankton die off. It's that 1-2 punch that really sets in hypoxia over large expanses of the Oregon coast. So what are we doing about this? This is tied to our global carbon emissions, so mitigating it is really not feasible. So we're left with responding adaptively. So we have partnered with Dungeness crab fishermen to monitor dissolved oxygen on the Oregon coast. This is a great partnership because as scientists, we're super interested in understanding the phenomenon, but crab fishermen also are super keen in understanding how the ocean is changing in the context of their ability to respond to it. So we have partnered with 8 fishermen in Oregon, and we were able to deploy a network of about 38 sensors. These dissolved oxygen sensors are low cost, and this has increased the observations by an order of magnitude in Oregon, which is really powerful. Let's see if I can click on this thing now. It's not working. Okay. I'll kind of breeze through how this works because Tracy actually gave a really awesome description of how everything works. But But essentially, you know, we've got our crab pot with our sensor in it. It's recording data. Fishermen will pull up and pull the gear and come on board. And then Pat will have his deck box on that is continually looking for these data loggers. And so when one lands on deck, it initiates a wireless data transfer. The deck box then generates a plot for people to see, the fishermen to see the data right there on deck, which is handy for them. They can factor that into their decision making. You know, oh, oxygen's low, maybe I'll go try somewhere else, I'm not catching any crab, maybe there's something going on. So they can kind of check and monitor it right there on the spot. The deck box also assigns a location, geolocates it, gives us some coordinates, and then sends it to a raw data server where I do some processing and then put it onto our public website so that anyone can log on and check out the data. If you do check out the website, we actually also are putting up some of the Massachusetts data as well. So there's a toggle for the East Coast, and you can zoom right over Cape Cod and see all the time series that the awesome partnerships out here have been collecting. So, you know, what have we learned from all this? Well, we have all this awesome data now that we didn't have before. We can see that these are plots from all 3 years. 2020 is right under the text, and then 2021 stacked on top of 2022. And we can see that there's a lot of variability. Oxygen is very differential depending on where you are. And, you know, having this information is super important because we can start understanding, you know, maybe there are areas that are more vulnerable or susceptible to the intrusion of low oxygen water. You know, based on the way the bathymetry is, maybe there's flushing going on and there's less retention time for hypoxia in areas versus others that are more susceptible to it. I've drawn the red dashed line on the oxygen plots. That is signifying hypoxia. And you can see some common trends that, you know, later in the season, we always see typically, you know, July, August, September-ish, we see hypoxia pretty consistently throughout a lot of the Oregon coast. But there's, you know, still some time series that are up and elevated. So it's nice to see that it's not all bad everywhere, which is handy to know. And this has been a great project to really be involved in. We've had a lot of challenges along the way. So, you know, we were one of the first ones to use this oxygen sensing system. It was developed for this research specifically, and I'm excited to see that it's going elsewhere and being used throughout the country now. But it was not always smooth. I worked a lot with Nick Lowell and Lowell Instruments to refine this, and they've been really great with iteratively taking suggestions and making it a better process. And the fishermen are always keen to give me suggestions and tell me why it's not working, and then we come up with plans to fix it and make it better. COVID was a big challenge. You know, I was handed this equipment in March of 2020, and trying to administer a cooperative research project where I couldn't leave my basement was very challenging. So I tried to set these up as best as I could and mail them out to fishermen. And I made some YouTube videos. I'm pretty sure my mom watched them more than the fishermen did, but that's okay. And really this kind of, another challenge was kind of identifying vessels that could participate. You know, there's no shortage of fishermen that are super interested in collecting data, but the crab fishery in Oregon is primarily wintertime fishery. So we see most of the landings happening between January and April, and fishermen will change gears and go target another species. So we're interested in oxygen in the summer. So this mismatch of, you know, finding vessels who are A, interested in science, and B, willing to crab the entire season is sometimes a challenge. But we've had a fairly consistent core group of partners that we work with throughout Oregon that have been really great to work with. And then, excuse me, and then trying to develop, you know, best practices for how to administer this project as it changes and grows, especially with kind of the back end that is the data side of things that a lot of people, it's not a sexy, people don't see it, but it is a challenge to be able to build up data products and debut things as the system's kind of changing. And I want to end on the successes, you know, because we've had a lot. It's been a really great project to be a part of. We've been able to increase the observations by an order of magnitude, which is great. In Oregon, there's really only a small handful of moorings that are measuring coastal dissolved oxygen. I split my time between this project and I actually work for OOI most of the time, the Ocean Observatories Initiative, people who have the Pioneer right here. And we have the Endurance Array in Oregon and Washington. So we've got moorings in the Pacific Northwest where we're measuring very similar parameters to those that are here in the Northeast. And let's see, looking forward to the future, you know, this is a common theme as funding for this. You know, we're trying to look for funding sources to continue this partnership and keep this momentum going that we've built up here in Oregon. There's a lot of interest in Oregon, specifically with the formation of the Ocean Acidification Hypoxia Council. There's a lot of kind of social and legislative inertia right now. So hopefully that we can kind of catapult this into something a little more consistent. And then lately we've been, now that we've kind of got a better handle on the project and the data side of things, we're trying to build up data products that are identified as useful by our fishing partners. And one of these is a hypoxia alert that I've been working on that will automatically detect data that comes into our raw server. If there's hypoxia present, it'll plot a figure and then send it to an email list. And then people get alerts if the oxygen drops down into scary levels. So that's a really cool thing to be continuing to work on. And with that, I'll take any questions. And we've got data here. It's all on our GitHub. And we have a website there as well that has all the data for everyone to see. So thank you.
Thank you, Linus. We have time for lots of questions.
Cool.
Hi, Linus. Anna Mercer, Chief of the Cooperative Research Branch of the Northeast Fisheries Science Center. I have two questions. The DO system that you're using in the crab fishery, is that applicable in terms of the sampling frequency for mobile gear?
I think the resolution on the In-Situ RDO Pro is 45 seconds, but I could be wrong. Battery life is a constraint with that. We have a 15-minute sampling interval for our study group, and we see about 6 months of battery life, which is fantastic. Yeah, but we haven't explored putting on a mobile gear yet, but I think the resolution might be a little challenge, and we don't have pressure, so that makes mobile gear hard.
Right. Yeah. Okay. And my second question is there any coincident either fishery or biological data collection alongside the collection of the dissolved oxygen data?
Yeah, so that's where we're hoping to go next. You know, how low is too low is a really important question. Because crabs are pretty hardy, it turns out. It's hard to kill them. So when it is low enough that they do die, it must be very low. So we've actually been partnering with the Washington Department of Fish and Wildlife, giving them sensors and equipment to put in their test pot fishery. So they've been collecting very detailed biological information and pairing that with our oxygen records. And we're going to start seeing some analysis come out of that. Yeah, thank you.
Hi, Giovanni Janison from Cooperative Research Branch as well. My question is, do you have any of these fishermen that have changed their fishing practices in terms of like wanting to get a read before they actually set their trap and, you know, maybe reconfiguring to just put it on a line with a weight or something so they can kind of get it up and back before they set all their gear? Yeah, that's a great question. Thanks. I've asked guys this, not to be leading or anything, but it's nice to know how they're using the data and if they're using the data. The resounding answer is that if there's not a problem, they just don't, it's not broke, they don't fix it, So they haven't used the data. They like to look at the data, but they haven't used it to make decisions. I think part of that is because they haven't been catching dead crabs, which is good.
Okay, we have time for one more question, and our break is next. So if there are other questions, you can
come find me. I'll talk to anyone.
Hi, thanks for that. Kelly Montanaro from NOAA's Atlantic Oceanographic and Meteorological Laboratory down in Miami. I'm sorry, you may have already covered this, but do you ever calibrate your DO sensors with in situ water samples? Like, are you taking titrations or something like that?
Yeah, that's a great question. I didn't touch on calibration, but we do calibrate these instruments. We do a pre-deployment and a post-deployment cal. We look for saturation and of oxygen and then a low point. So we do kind of a 2-point cal. We don't collect any bottle samples with our measurements, but I have this cute little bonus slide here where I've compared all of the oxygen data from our crab pots. We've got one that's very close to a pretty nice oceanographic mooring, and we can see that it's like pretty good, consistent observations that are reasonable for being that close away. I mean, they're 3 kilometers apart, but they have very good overlap and agreement. And we've calibrated these, probably over 100 times. And the royal we, I have, and we've seen about a 0.003. Is that right? 0.03. Sorry, 0.03 milligram per liter, plus or minus 0.03 for each individual observation. So we have really good confidence that this data is good.
Great, thank you all. Please join me in giving a round of thanks to our speakers this morning. So I would love to introduce Miguel Santos, who is here from the Portuguese Institute for the Ocean and Atmosphere for our first talk this second half. Thank you.
So, good morning. I belong to the Portuguese Institute for Sea and Atmosphere. It's like NOAA, but with a very, very lower budget, of course. And I also are a researcher of the Center of Marine Science of the University of Algarve. And what I'm going to try to present you in 15 minutes is my more than 30 years of experience working with fishermen in Portugal. So, fishing vessels of opportunities are being used for a long time to collecting atmospheric, oceanic, and biogeochemical data. Mainly the vessels that are used are cargo vessels, and these are good platforms for if you want to build a long time series in a specific route, but as of course a coarse spatial resolution. And for these fishing boats probably are the best ocean observing platforms, but they are not fully explored at the moment. So the motivation in our case is because Portugal is sea. About 98% of our territory is in the ocean, so it is very important that we have this kind of observations on our seas. So I started to work with fishermen in 1989, and this was under a project that was called SatOcean, that is using satellite remote sensing to support the Portuguese fisheries. And we work with fishermen from Peniche that they use longliners for catching swordfish, and they kept us information about temperature with a simple bucket thermometer. And as you see, we could compare the satellite sea surface temperature with a bucket thermometer. So it should be here an image of the vertical profile of temperature along the time, and it was used with these XBTs sensors that we install into fishing boats, and they kept us information because it's a long liner. They deployed these XBTs in the beginning, on the middle, and on the end of the setting of the long liner, and also when they recover it. So we have a very good time series of vertical distribution of temperature during the fishing season. After 10 years after, we try to work with another kind of fleet that is a fleet that targets black scabbard fish. That is a deep sea deep sea fish, and they use bottom longliners. So we use these TDRs that put on the buoys of the gear. And with GPS, we have this information when they deploy and when they recover the gear. And we published several reports because this is under an European project. And as you see, we can have the vertical profile of temperature when they deploy and recover the gear, and also a long time the fishing is fishing. And with this, we could have a distribution, a seasonal distribution of temperature along several months. And this worked very well. The only problem is this is a very, very deep fishery. It's more than 1,000 meters, and at times this kind of sensors have some limitations for these depths. Now, presently, what we are trying to develop is an autonomous, completely autonomous observing system. And because we are also the meteorological office of Portugal, we want to also to have information about meteorology. So we are installing weather stations under the VUS program, and also a kind of ferry box developed by a Portuguese company, so that could measure several parameters depending on the sensors we put. So at the moment we have sea surface temperature, sea surface salinity, chlorophyll, pH, dissolved oxygen, oxygen redox potential, and turbidity. And also we use gyro compass to understand the motion of the boat. With the motion of the boat, we can have estimates of sea state like waves. I will not talk about this because this is developed by the University of Lisbon, a group of engineers, and it's not still operational. So all these information after go to a cloud, and the idea is to develop products for the end users. So we want to be a win-win situation. So the ferry box is mainly a small, as you see, it's very small, 30 centimeters more or less each side. So it has GPS, it has a water inflow of water from the surface, water out, and also fresh water in to clean the sensors after every measurement. The idea is that this could be, the data could be stored in the ship, but also could be transmitted if the ship is near the coast, transmitted by GSM, or if it's far, by satellite in Marsat or something like that. Or Iridium, that is it's cheaper. So I'm going only to show you that we are now already installed this in a cod trawler. In this case, he goes to the Grand Banks on Newfoundland, and so en route to the fishing grounds, as you see, you have a continuous observation of all parameters. And as you see, it is installed. It's very easy to install, and the only thing you have to have is in and out of water. And recently, he went to the fishing grounds of the Barents Sea. So as you see, we also have the information Also, as you see, we can have this good and cost-effective way to have all these measurements, and even we have the catches here of the first already of the first leg that he made to the Newfoundland. And what I want to transmit you is that fishing vessels have enormous potential for continuous observation of the seas, because you are always or almost always at sea and almost in all weather conditions. So if we have a cost-effective system, we could have a very good spatial and temporal resolution of the parameters in the ocean. So probably the best way of have some information that you could not observe with other systems, for instance, surface air pressure and vertical structure of the ocean. It could be only obtained probably with these systems. So this could be essential for ground truthing of satellite observations, but also for weather prediction models and ocean models. And because there are a lack of this subsurface data, this will be the best way of having this information. And so I think it's all that I want to transmit to you.
Thank you very much. We have time for questions.
Thank you. I think probably your unit is out of the price range of our fleet, small boat fleet, and I'm suspecting requires a lot of care and maintenance. But I'm curious what the cost of one of those is, and how, you know, what sort of requirements for maintenance there are.
These boxes are a type of ferry boxes. Usually the research ferry boxes are very complicated, are very huge, and so it's very expensive. This one is very cheap. So it is a small company that are developing them, and so we can have the cost is about 10,000 euros for installation, and every year 5,000 for every year. And what they do is they, instead of maintaining it in the boat, what they do is to change every three months. They change the boxes, and is in the cost of this year program. No, yes. No, it's because it should be very cheap to have a lot of these systems in the fishing fleet. It's not very good. And if we put also sensors into gears, we have the meteorological information, the surface information, and also the vertical. So we have all this information in one system. And the idea is to do that.
We have time for one more question, if there is any. Right. Well, then I would be thrilled to introduce our next speaker. Our next speaker is Anna Mercer, who will be joining, who is from the Northeast Fisheries Science Center.
Can you hear me? Moving, huh? All right, well, while we're figuring out the technology, I'm going to talk to you about a different study fleet. You heard about a study fleet in Cape Cod Bay this morning that was focused on dissolved oxygen monitoring, and I'll be speaking to a study fleet that is across the Northeast region. And before I get going, I wanted to recognize the folks in the room who either participate in, currently have participated in, or support the program. So please raise your hand if you have been or are currently involved in the study fleet. So most of the people that you see are industry members who either have in the past or currently participate in the study fleet. And then Giovanni Giannessin, who's right over here, raising his hand. He's our field team lead for the study fleet. So I just want to give you a sense of who you can talk to after this if you want more information in addition to me. We have issues? No. Good. All right, so let's jump in. The first thing I wanted to do is just give you a sense of where we're coming from in terms of the organization that I work for. So I'm the chief of our cooperative research branch at the Northeast Fisheries Science Center, and our mission is really to bring fishermen into the scientific process to inform both the science that we do, but also fisheries management, which is the other arm of NOAA Fisheries, of course. We do this in many ways. So today I'll be speaking about one specific program, the study fleet. We also run surveys. EMOL is part of our program and collect biological samples. So I'll be focusing on a couple of these bullets here in terms of providing tools to fishermen to help us get the data that we need to better understand the ocean ecosystem, but also really working on fostering those partnerships. There's a lot of historic distrust between the science and the fishing community. And so my group at the Northeast Fisheries Science Center plays a critical role in our agency of breaking down those barriers and developing trust. And everything we've heard today is working towards that. Here we go. Okay, good. All right, so for those of you who have never heard of the study fleet, the Northeast Fisheries Science Center study fleet, it's a program that started in 2006 as a way to engage fishermen in collecting detailed information about what they're catching, where they're catching it, and what the environment is like in those areas that they're catching it. As a part of this, particularly since this was a decade and a half ago, there's been a large focus on technological development. The focus in the beginning and currently still today is developing an electronic data collection system, so trying to take paper out of the equation. And we're focused both, again, on what they're catching as well as what the environment is like. So I'll focus on that latter half today since that's what we're talking about. But I'll give a sense of just a sense of what the data looks like as well from the fishery side. Currently, we have 52 fishing vessels that are participating in the study fleet. We're recruiting 5 more actually this spring, in part due to just simply retirements or vessel sales that have happened in the last year. And most of those vessels are trawl vessels. So we've heard a lot this morning about these industry-based environmental monitoring programs based on fixed gear vessels. This program is primarily focused on mobile gear and primarily trawls. We do have a couple of gill netters that participate, as well as scallopers, a couple longliners, and a couple hook vessels as well. But again, the gear that this system is deployed on is usually mobile fishing gear. In terms of our spatial coverage, so you can see the map here on the bottom right, just showing you the spatial coverage of where these data are coming from. So to orient you, we are right about here. So you can see that we have coverage all the way from the Gulf of Maine down to off of Cape Hatteras, and really the areas of focus that we have the most data density are in the inshore southern New England area, as well as out on the continental shelf break. And of course, this is where people are fishing. We are not asking any of these fishermen to collect these data where they're not fishing. All this data is coming to us from their commercial fishing practices. So that's why you see the spatial distribution that you see. You see Rodman here. Rodman, raise your hand. He's famous. There he is. There's Rodman. Rodman collecting data. He may or may not be posing in that picture. But there's Rodman using just one of the tools, which I will talk about next, actually. Okay, so how do we do this? How do we engage fishermen in collecting this data? How do we make it as easy as possible? Because that is the goal. When they are fishing, they are fishing. They are fishing for dollars. This is their living. And so we are trying to minimize the burden on the fishermen who are participating in the program. The first step, of course, is to get vessels into the program who are engaged and interested in making the extra effort. It does take time, and some of the industry partners who are here today can speak to the time that it takes for each of their gear hauls. Then our team goes to their vessel, Giovanni, or our other field team staff, and they install our data collection system. And you can kind of see a schematic of there. The formatting got messed up, but you can see a schematic of there on the top. Once that data system is installed, the captains can then record those data using the tools that you can see here. So for hardware that we install on each of these vessels, each vessel has a PC laptop, so it has to be a PC, and then it has to have certain specifications which I'll talk about in terms of challenges later. We hook that laptop into a GPS, either their vessel GPS or one that we provide directly into their laptop. We hook that into the depth sounder as well as their VMS or their vessel monitoring system. That allows them to transmit the fisheries side of the data to us through that platform if they choose to do so. And then what I'll be focusing on today, of course, is the environmental data collection component of this. And for that, we use the Aqualogger 530WTD. Those are the sensors that we deploy or that we install on the fishing gear for each of our study fleet participants. Of course, we have software, as everyone does, to go along with these as well. Flounders, or the fishing logbook data recording software, is a PC piece of software that goes on that laptop that prompts the fishermen to enter the information about their fishing effort as well as what they're catching. And this happens for every gear haul. That is the really unique component of this program in comparison to other fishery monitoring efforts in the region, is that this is at the haul level. So we have really high resolution data of where fishing is occurring, what they're catching, what they're throwing over, and then ultimately what the environment is like in those areas. For the environmental data, on those laptops, we also have AquaTalk, which is a piece of software provided by Aquatech, the company, that allows fishermen to view their environmental data in real time. And then recently we developed a tool called GoFish, or the Graphical Onboard Fishing Informatics System homepage. Oh, Noah loves acronyms. Oh, so many acronyms. GoFish, just call it GoFish. And that's what you see down here. And this tool, it's an R-Shiny app for those of you who are R-Shiny people, allows fishermen to visualize their data on the fly. So this can integrate all of the data collected by individual fishermen over time and allows them to look at it over space, by species, in comparison to ocean currents, temperatures, and to do some kind of simple modeling as well. This is a tool we've very recently developed, and we'll be rolling it out in the next year or so. All right. Moving on to the focus of today, our temperature and depth monitoring system. The components you can see listed up here, again, we use that Aqualogger 530. I listed just some of the specifications for that logger in case you all are interested, and tech geeks in the room. And you can see a picture of that logger attached to a scallop dredge there on the top left. In addition to that logger, which of course is inside a housing and installed in the fishing gear, we also have a Bluetooth antenna that's installed on each of the vessels that allows that logger to talk to the laptop, to AquaTalk, which ultimately is how, after each gear haul, the fishermen can view their data. So that's what you see on the top right there. That's a screenshot of AquaTalk. I think that's from the Cody, where every time that probe is hauled or their gear is hauled back, it automatically, if it works right, talks to that program and plots it up for the fishermen. Once that data is collected and is on the logger as well as on the laptop, there are a few steps that we take for loading and processing the data. So as you might take from what I just said, this is a real-time system in terms of fishermen having access to the data. It is not a real-time system in terms of scientists having access to the data. So we have to go to the vessel and offload those data, Giovanni knows this very well, and bring them back to the office and upload them into our Oracle databases. So it is real time for fishermen in terms of getting those data back. It is not real time for us. And if we're talking about challenges and limitations, it's a real limitation of the system in terms of using it for real-time ocean monitoring. We are able, which is what the screenshot is showing you here, to actually match these temperature and depth data to catch and effort data. That's one of the really valuable parts of this program, is that we have coupled temperature, depth, and catch and effort information, which is really unique. I'm really just starting to dig into the value of that in terms of using it to understand environmental drivers as well as climate impacts on the fisheries in our region. In terms of the data availability, I already spoke through this. That raw data is available to the fishermen in real time. We gotta wait. We give it about a year or so for us to go through the auditing and matching process to make those data available. And in terms of the reliability, the system, we are estimating back of the envelope about 75% of the time, this temperature and depth monitoring system works perfectly. Other times, there's one component or more than one that's not working. So just keeping it real. All right, so I'm not going to go through all of these. I'm happy to talk through these, and really the folks who are using it can go through some of these as well, but some quick strengths. The loggers are really robust. They're really robust to being deployed on commercial fishing gear that is bouncing over the ocean floor and running into stuff. The antenna that we use does hold up well over time. Essentially for us, the battery life is really good for these. They're about 18 to 24 months before they have to be swapped out. And then the fishermen get that automatic feedback. Of course, there are a litany of challenges or weaknesses in terms of challenges with mounting, signal interference, particularly on large vessels. International shipping, this is an international company, so that ups the cost for us. And then some of the other challenges related to downloading and manually uploading the data, as well as the requirement for a Windows computer or laptop. All right, so lastly, where I just kind of wanted to land this is how do we use the data? This program's been going for just over 15 years now, and we've had several successes of applying the catch and effort data, but also the environmental data side of the program. So the first one that I wanted to flag was the development of thermal habitat models. So those of you who aren't fisheries folks in the room, those are just the environment that fish like to live in. And so we've done that for butterfish as well as Atlantic mackerel. That was a really essential part of the butterfish stock assessment a couple of years ago. We've also been using this information to explore ecosystem drivers and oceanographic drivers of some of our resource species. Recently, we've done this for short-fin squid, northern short-fin squid, or ilex squid. Noelle, wherever she is, spoke a little bit to some of the work that we've done there and collaboration that we've had, as well as looking at these data for Atlantic herring distribution by depth and temperature. We're also integrating these in-situ bottom temperatures into the catch per unit effort indices that we develop for our stock assessments, and I've listed a few examples for species where we have applied those indices and these bottom temperatures as a covariate. And then we've also started to use this data to understand the impacts of offshore wind. And I'm not going to dive into that because that's a wormhole. But we have been able to use this really precise information about where fishing is occurring in the environment and where it is to kind of predict the changes on fishing operations and ultimately inside the environment. In an area I'd like to see it used more, oceanographic modeling. So I hope to have some conversations with some of you today about how we could do that better. And I believe that's my last slide. And I have to take questions. Thank you.
Thank you, Anna. We have time for questions.
Do the fishermen see any temperature, the catch rate corroborate with the temperature? Do they use that information to help them to fish?
I would say my answer to that is it depends on the fishermen. The fishermen who are here in the room can certainly answer that question. I'd say recently, I have certainly been communicating with squid fishermen who are using this. Squid are highly sensitive, of course, to the environment. And so they have the vessels that have these tools on their boats have been able to use them to better target. But Jim is a groundfish fisherman. Mike over here is a scallop fisherman. So I'm sure they could speak to ways in which they may have used this as well. I do think it depends on the fishery, and on the fishermen as well, in terms of how savvy they are in applying it to their fishing practices. Mike or Jim or anyone else want to answer that? Chime in here for a second. I'm happy to share the floor.
We kind of have to just fish with where we fish. But, I mean, we've definitely noticed in the Gulf of Maine, the temperature is definitely rising, and that's hurting the fishery for sure, especially on cod and other species. But
thanks, Jim.
And just also a quick plug, this afternoon after lunch, we'll have a panel of industry members who are hopefully going to be sharing their experiences and perhaps how they may have used their data. Are there any more questions? We have time for one more.
Yeah, Nick Lowell from Lowell Instruments. You were one of the few speakers that didn't say that one of the issues was funding being limited.
It is.
I'm just wondering, could you describe what the funding situation is at the federal level here?
Yeah, I'm happy to. So for those of you who aren't aware, there is a cooperative research appropriation. Oh, let's get into Congress. Congress appropriates money, your tax dollars, every year to support cooperative research across the nation. So every region, Northeast, Southwest, Alaska, Pacific Island, Southwest, Northwest, they all have cooperative research programs. As a part of that congressional appropriation, we get language that provides us with direction on how to spend those dollars. This program was started in response to some of that congressional language, and so we continue to use those appropriation dollars to meet those priorities, which provide stable funding over the years. I'm happy to provide more information about the cost of the program and all of that if you'd like to at another time, but it is related to congressional appropriation. Trending flat. we are very flat. So we've trended down since 2010 significantly by about 10 million. And now we have been stable. We've been just about stable for the past, since I've been in this position, about 3 years.
Great. Thank you, Anna.
Of course, my pleasure.
So our next speaker today is Brendan Turley, who is coming from the NOAA Southeast Fisheries Science Center.
Thank you. So switch gears a little bit, different regions. So I'm in the Gulf of Mexico. I'm here in lieu of my fishermen collaborators, so I'm a NOAA affiliate. They are hit pretty hard by Hurricane Ian, so I'm going to talk about what they've done, what we've done collaboratively. So first, acknowledgments is always important. My fishermen collaborators, FCWC, Florida Commercial Watermen's Conservation, KCJ, John Mertz, our state partners who are very instrumental in monitoring red tide, University of Miami folks, also NOAA affiliates, folks on the RV Walton Smith, and my NOAA collaborators, Chris Kello, Mandy, Matt, and everyone else who works on the ships have been amazing. So I'm going to speak to the choir here, but this is, I think, is important to kind of point out that, you know, the marine environment's undergoing complex changes. There's multi-stressors going on, and a good solution, a potential solution or partial solution, is to enlist or collaborate with commercial fishermen because they're on the water every day. A little bit about who I represent. So I work with the Gulf of Mexico Integrated Ecosystem Assessment Program. That's a NOAA-wide program, but each region has their own. And we're a group of ecosystem and social scientists, and we really try to integrate all the different factors that you can think about that affect the ecosystem in the Gulf of Mexico to try and get at real good science to help management, really focusing on that management aspect of it. So this will be a little bit of a story, and it goes back not that far, but it goes back even further. But it kind of started in 2018, where folks at the Southeast Fisheries Science Center went out and did local ecological interviews, where they went and talked to the community to find out what concerns them most about the ecosystem. But also there were several participatory workshops to also kind of elicit this response from the community, the fishing community particularly, of what concerns them about the ecosystem. Because as we move towards ecosystem-based fishery management, we need to know what's important and what the fishermen see on the water, because we don't always see it. So like I said, in 2018, it was during a bad red tide. There's several communities that were kind of involved in this on the west coast of Florida. I'll show you a map if you're not familiar. And total, there were like 62 oral histories. It did some mapping, and this also ranged from commercial and for-hire fishermen, which is also very important in the system. So this is a map of Florida, and all these dots. This is from the state of Florida. They're at red tide monitoring. Red is really bad. Yellow is okay, or not great. White and gray are, you know, not that big of a deal. So Florida red tide occurs annually between, you know, late summer, early fall, almost into December. It's caused by a dinoflagellate that produces a neurotoxin, which causes respiratory distress, and it can lead to massive fish kills, but also kills of megafauna, and can infect people on the beach. Shellfish harvest and aquaculture shuts down when it reaches a certain level, so it's important and very influential in the industry. And then also, hypoxia tends to occur when red tides start early and linger through the summer, when we're starting to see more and more frequently. So this is a concern. And what came out of those participatory and oral history workshops was this idea that fishermen have the ability to let us know what's going on in the water. And so kind of, this was driven by the fishermen, really. They decided to band together and to actually form their own nonprofit and to start then monitoring the ecosystem. It was a community fundraising event to get these 4 sensors. They're in situ aquatrolls, which are kind of like the YSIs that people are familiar with. And we use them to get like water column profiles. It's volunteer-based. We're very funding limited. I mean, I'm like the science. You do see the science back right up here. They try and sample at several locations during fishing trip. And this is primarily, exclusively at this point, on the hook and lines grouper and snapper fishery. So these guys have to actually physically lower into the water. Very hands-on. So this is just a snapshot of one of the bulletins we produce. But really what we do is we do collaborative water quality monitoring with commercial fishermen, and they own the data, they're data owners. We do the science support and the data processing and produce a data value-added product back to them, but also use it in fisheries management applications. We also integrate regular surveys. So the RV Walton Smith is University of Miami's ship, and they do bi-monthly surveys along the Keys and on the west coast of Florida. But also NIMS does their own surveys, and we try and integrate as much of this data as possible back to our collaborators, the fishermen, but also to the management process itself. There's a dashboard right now that's undergoing multiple changes, and really like a big value that we have that we're trying to work towards is building this communication network. Because right now it's like the grapevine. This guy heard from that guy, especially in regards to hypoxia and like our stone crab fishery. So it's important to build those connections, and this is kind of some of the initial stages. And just to kind of tell you about the plots, these are the 4 parameters we typically see is bottom temperature on the upper left, bottom salinity, chlorophyll, and dissolved oxygen. So to kind of give the fishermen some idea of what the conditions are near the bottom. And this is just an example of how it's done. So here's our aquacontrol unit. The cylinder the guy's got turned on the sensor. You can use your phone, which makes it really convenient and don't have to worry about a tablet, because we've had Google Drive password issues and security issues. They place it in the water, let it soak, and then lower it down. So it's a pretty hands-on, very manual sort of process. And total water on the time depends upon depth, because the shelf is pretty shallow. Like the shelf break is 100 meters, but that's 200 kilometers out. But 2 minutes per drop is not that much, but when you add it up, total time to stop, get the unit ready and put it in can add up after a while. So this is a barrier to participation. It's like, okay, we're gonna go out fishing, but if I agree to do this, like I have to add on a certain amount of time to actually do this. Or if I don't do it when I go out, I'm tired, don't wanna do it when I come back in, don't get data. So it's an issue, which I totally understand. So I kind of mentioned that this information has been used for management purposes. So there's 2 fisheries in particular that are affected by red tide, and the red tide is included in the stock assessment process. So right now, for red grouper and gag grouper, they include a discard fleet only, and that's a little bit of lingo for stock assessment process, but it's just an episodic mortality that can turn on and off when there's a bad red tide event. And so the surveys that I talked about, the Walton Smith, the NIMS surveys, but also our partners, SCWC, this survey data has been combined and kind of integrated into like environmental context. So for example, last week, the Scientific and Statistical Committee for the Gulf of Mexico Fishery Management Council was talking about the red grouper update for the stock assessment. And we're undergoing a red tide right now, which is kind of unusual being wintertime. And we give them data to tell them, okay, we're at least not seeing hypoxia, because that really is the ecosystem effect that we think most affects the fishery. And something that's important that we're trying to stress to our collaborators, this last point, that using this ecosystem information doesn't always mean quota cuts, because there's a concern like, oh, if there is a degradation of environment, which is kind of the perception, that could lead to only cuts in the quota. However, last year we showed that there wasn't much of an impact from red tide, so the Gulf of Mexico Fishery Management Council actually didn't cut quota as much. Like they always, approve changes to landings, but they decided that because there wasn't necessarily an impact of red tide, that they were going to go less conservative, higher landings. So some of the wish list. So this is an example of one of the bulletins I can talk about more, because I have a table and a flash talk. We want to understand red tide and ecosystem impacts. This is really the big issue. And then eventually that could hopefully plug into forecasting red tide and hypoxia. So some people have talked about using this in oceanographic modeling. This is definitely like a direction that we're moving towards. We also try to provide the fishermen with value-added product for their use in business decisions. So this is a bulletin. We try to point out like, you know, obvious oceanographic characteristics that we see that we think are important for like ecosystem that they could use in their fishing operations. Now, if they do, is a different story. We'd like to move into other fisheries. So like the stone crab fishery is very big in Florida. It's also, you know, it's a bottom fishery, so hypoxia is very important. But also into other regions of the Gulf of Mexico. We're also working on tracking red tide with satellites to try and integrate it into our system, but that's still a work in progress. And some of the challenges are is multifold. I mean, we all have challenges. All the challenges everyone has already said, we've had. But also differences in opinion on what the goals of our collaboration is. So our fishermen collaborators have their goals, we have our goals, and they don't necessarily always align, so that's caused some friction. Stone crab fishery, they're very wary of federal involvement. So I may be a University of Miami employee, but I wear a federal hat. COVID shut down regional fishery demand. Piney Point disaster is a whole nother thing. Politics of quota allocation, that's the recreational versus commercial sector is huge in Florida. And Hurricane Ian decimated our collaborators. Like the eye of the hurricane hit exactly where they're based out of. And that's just a picture. Actually, our collaborator's fish house is right here, and there's a long line that ended up in the back of his seafood market. So we've had some challenges, and things are kind of on hold at the moment. With that, I just want to end with, you know, commercial fishermen are very influential and impactful in understanding what's going on with red tide, and we really try and be responsive to the community. And this is just an example of our bulletin, and definitely, you know, let me know if you have any questions.
Thank you, Brendan. We have time for questions.
Thank you, Brendan. I've got a question about this bulletin. How often do you put this out?
It's just when there's data collected, which right now is kind of sparse.
Sure. Have you gotten feedback from the fishermen that you've worked with on putting this together? Do they?
It's been we've gotten some feedback, but ultimately, because of all the challenges we've had with like COVID and hurricanes, not just Ian, the data collection can be kind of sparse. So these bulletins come out in sparse, you know, sporadic. We've had more feedback from the council because we've used it in council, you know, process. The fishermen we're still working with to understand if we're really meeting their needs or if it even is a need that they need. Makes sense.
Good morning or afternoon. Thank you very much. You said you're looking to improve communication networks, and I've got a lot of experience with social, radio, and computer networking, and I'm really kind of curious if you could elaborate on that particular point. Oh, sorry. My name is David Kovar. I'm with my own startup, not with a government agency. Thank you.
That's a challenge. I wish I had a really good answer for that, but it's been a struggle just because of the politics of the fishing in Florida is really, like the recreational versus commercial, there's a lot of friction between those communities. So trying to build this network has not been easy.
You're talking more about building this, you're talking more about building the social network involving the various constituents, stakeholders, and contributors to it more than the technical network.
Yeah, the technical network is, yeah, I'm talking about the social connections, absolutely.
Okay.
Right now we're kind of siloed.
Thank you.
Great. We have time for one more question.
Thank you very much. I've been hearing a little bit about whispers of the program, so great to finally meet you and stuff. So talking about hurricanes, and you're at University of Miami and AOML and everything, have you talked to the hurricane forecasting folks?
Yes, actually, we're talking right now specifically with Ian because we're kind of expecting to see some hypoxia because there's actually a red tide that's kind of created by the hurricane in some respects. It's kind of but yes, we're in discussion right now with the hurricane folks to better understand like the ocean dynamics.
I think I'm thinking the other way around. Oh, it looks like maybe I'm up next. But like Mathieu Lehanf He's and so we were talking to him about setting up a network in the Bahamas, and he's like, oh, any shelf region in this area is like a super blind spot for ocean heat content. So I think there could be a win-win there.
Yeah, I mean, we're still looking for ways to fit this data into needs, right?
Okay.
That's what you're talking about, right?
I can help you with that.
Yeah.
I think.
Cool.
Yeah. Okay.
Great, thank you very much. So that's an excellent segue here. So I'd love to introduce our next speaker, Cooper Van Franken, coming here from the Ocean Data Network.
Sorry, I thought there was one more coming up. So anyway, thanks everybody for being here, and great to see everybody. I'm going to kind of completely flip around what I normally do for a presentation, and somebody introduced me to this idea when I was explaining what we're doing, collecting data and saying, the fishing industry is always at the most interesting areas, the edges, the shelf break, anything like that. And this guy, Miles, he's from Colorado. He doesn't know anything about the ocean. But he's like, oh, that's super interesting. I dig that for sure. And, saying that like he's got this bigger theory that the edges, the convergences, the mixing, that's always where the most interesting stuff is happening. I've been thinking about that a lot since then, and I think that pattern extends, far beyond this. And so it's, led to a little personal introspection, and I think frames quite well what we're doing and our approach to all this. So, that personal introspection, my own background first, kind of coming from engineering robots. I quit that. I don't like robots, and I don't care about airplanes that I was building. So then I moved back home to Maine, fished for lobster, then fished in Alaska for a short little bit, and then went into fishery science and kind of combining all of these perspectives and, getting frustrated with kind of the classic the issues with traditional fisheries management, and seeing light at the end of the, a new frontier of science, which is linking the environmental factors to the stock health to understand the booms and busts and all that we're all very familiar with. But, satellite sea surface temperature isn't going to work very well for cod that are 100 meters below the surface down at the bottom. So, to me, the obvious solution is, get data where the fish are. How do you do that? Stick some sensors on the gear. So I'm super keen on this whole idea, and then kind of look to the side and say, oh, what's the cutting edge for ocean observation technology? And there's a lot of folks talking about robots and a lot of really interesting engineering there. But, from my perspective, we shouldn't be sending robots out into the ocean when there's already thousands and globally millions of fishing vessels out there. Let's send the sensors along for the ride. And, my thesis is that in many cases, fishing vessels as platforms are a better tool in some of the most interesting edge areas. And then, so looking at, hey, does anybody else need this data where the fishing is taking place? And it turns out, yeah, everybody needs data. And really counterintuitively, we are lacking data in the coastal regions. We've got plenty of data in the deep open ocean where things are moving more slowly, but then in closer to shore, there is no data. And, most of us know this is where most of the fishing takes place. So it's really this perfect kind of yin-yang solution to fill these pressing data gaps. And then, this pattern is repeated around the world. I think in the next presentation, we should have some similar pictures from New Zealand, from Julie Jakubowski. And then, so our role, my background, and then the team of folks, coming up with me, that's Jack Carroll. Carlace is on a boat in the UK right now, testing some seine net stuff. Our role, seemed to be we could make a better impact by filling this gap between science and industry. Staying light on our feet, moving quickly, and supporting this concept anywhere where it was needed. That means we do a lot of data management, facilitating knowledge exchange, showing everyone else what everyone else is doing. And then, on making this presentation, I was thinking, we're actually working pretty evenly now for science and for industry. It started, our first contracts were for the government collecting data, but now we're doing a pretty even mix, which I think is cool. And then, so kind of the most full service thing we do is instrumenting fishing vessels to meet specific data needs. So this is a network, it's only 4 vessels. And this is part of an ONR project centered around the Pioneer Array. So fishing vessel points are in blue, and then OOI Pioneer Array points are in yellow here, these 6 moored points there. I want to show this for two reasons. The first, holy smokes, look at all that edge, right along that shelf break area in that super interesting spot. And, trying to do that at scale with conventional ocean observation technology, you cannot do that. Those buoys are super, super high resolution. They cost millions of dollars, and so it's a great tool for really high resolution. But if you want to look at this spatially distributed and look at scales, to me, the scales that we need to be looking at for fisheries and operational oceanography, this is the way to get that. And the second piece is, this is a comparison of the data quality coming, so downcast, upcast from a crab pot mounted sensor over there on the table. I meant to bring it up with me. And then this is the offshore profiling mooring. So you can see that it's accurately resolving that temperature structure down almost to 700 meters. So this is super deep. And so, the conclusion there is not, we don't need Pioneer Array. The conclusion is that these two data streams complement each other. The Pioneer Array shows kind of a ground truthing and can, validate these observations. And then the fishing vessel observations can extend the effective coverage of these higher resolution platforms. And so it's not just us or even the folks that are here locally. We've heard a little bit about this from Miguel Santos and more internationally, but there are quite a lot of programs popping up around the world. And but I do want to note that I think Jim Manning in the back there, he may have a pretty decent claim to being the first one to ever do this. And so Jim Manning, and then not long after that, there's the FOOS program in Italy and Recopesca program in France. These are kind of the key early pioneers. Things were a lot more difficult back then with the tech, so we're really standing on a lot of decades of hard work. So it's important to recognize that, and thank you all for that. And now, in more recent years, there have been some newer programs, but that are really doing this at a super ambitious scale. Kind of changing the game. And so after my talk, I think Julie's coming on with the Moana project. That's one of these programs at really impressive scale. But I want to showcase the Japanese program, which is one of the ones that I'm most excited about. And so this is now over 200 vessels, which are contributing both CTD, so temperature and salinity, and ADCP data. So that's current profile data, so the current from the top down a little bit. And that's assimilated into a custom ocean model, then delivered via Android application to the captains. This is done by Nick Hiros's group at Kyushu University. And these quotes are translated from Japanese from the captains there. It's been a game changer for them, and they're making more money. Their operations are safer. Yeah, so this to me is kind of the pinnacle of the stakeholder feedback and something that we can look to as a pretty interesting example. And then, another side piece of this, I've been talking with a few of you about getting the CTDs or a version of those made for us so that we can import that instrumentation into the US and start deploying that over here. Which speaks to, there's a lot of opportunities to share and exchange knowledge between these different programs. And so, when I came on the scene in 2018, I started, talking to people very informally. To Jim, I was super psyched to meet him in person for the first time. I remember that very well. But, now a few of us have come together to formalize a group, FV-ON, Fishing Vessel Ocean Observation Network, which has the goal of formalizing this group and promoting knowledge exchange at a global scale. And ultimately building towards fishing vessels being an accepted platform for ocean observation anywhere as part of GOOS. So that's the Global Ocean Observing System. That's that top level. And this is the track that's been taken from gliders, HF radars, a lot of these more conventional platforms. And so this is the route to bring us all together and to facilitate this. Community white paper coming soon, then looking towards a UN Decade of Ocean Science action endorsement. And so, myself, Miguel Santos, he's involved with this. Jim Manning, of course, in the back. Hassan Mustafid took my car to go get something. But he talk to him about it later. Michaela online, Julie. So you know, would love to tell you more about this and get some more input. And so, you know, to wrap things up, I'm super thrilled to be here. And, you know, this is probably the most interesting group of people I've ever kind of sat at some kind of sciencey event. And to me, this is like, it embodies this kind of idea of convergence on a whole nother level that you don't see very often. So thank you all for making the journey here or attending online. But also special thanks to Alec, May, Jenny, the rest of Heather, the rest of the folks at WHOI, and having us here, and really looking forward to the next couple of days.
Great. Thank you, Cooper. We have time for questions.
I'm Glenn Gorkowitz. I'm a physical oceanographer here at WHOI. Cooper, wonderful talk. And I thought that was a really amazing slide that you showed about the profile data off of Alaska, with all those profiles in the deep ocean and the continental shelf being relatively sparse. One of the things about the continental shelf is that the timescales are so much shorter. And for the shelf break, which of course I loved you highlighting, the decorrelation timescales, the statistical differences are 1 day and about 6 nautical miles there. And so it makes it even, you know, more difficult and more of a challenge for the ocean modeling there. So I just wanted to reinforce that one point.
Okay, thank you very much. And it's great to have that technical, you know, validation of that. You know, intuitively, it's made sense to me. It's like things are changing way more quickly. We probably need way more data, but we got less data. So, you know, but that's the real answer that Glenn just gave.
We have time for more questions.
Alec Wong from WHOI. Wonderful talk, and this is great. I particularly like the example that the Japanese folks did. I think the last point you made using this forecasting model that tells the circulation and the current. That's a very powerful example that, you know, help the fishing industries to actually you know, benefit their operation and then use the product directly from that. That's a very powerful example. I hope that this is, I mean, if we're adding more chemical sensors, the oxygen, pH, I hope that's kind of example I really hope that can help the industry.
Thank you, Alec and Cooper. Are there any other questions for Cooper before we move on to our last speaker of the first session?
Hi, I'm Brandon Phillips. I'm at University of Rhode Island. I'm an engineer. I'm just here mostly as a fly on the wall, and I'm not sure where to insert this comment, but I think it adds on to what you're doing. It struck me that you're using fishing vessel data to validate, or vice versa, with buoy data. And that means that there's a motivation to go near the buoys and to connect those data points occasionally. And then I'm also thinking about some other notes I've had throughout the morning, which is connectivity of sensing from boats. Like we can get sensors off boats, but how do we actually get that data uploaded to the cloud? There's some great examples of the workflows that are good. I've seen in almost every presentation challenges associated with that. And then one other note is incentives to participate in the program. Seems like most people are incentivized, but there could be more. So where I'm driving at is I'm wondering if the idea has been brought up before to use buoys as data hubs, like live Wi-Fi centers, so that fishing vessels are motivated to go near them and then have their data that they're collecting upload to the cloud. Is this done? No. It's expensive.
You guys are thinking along the same lines.
Yeah. Fine.
Yeah.
I just wanted that, I wasn't sure where to say it, but it's just the root of a lot of these challenges I'm hearing has to do with the connectivity. And I think it should be offshore, not coming back to the dock. Okay, that's my point. Thanks.
Great, thank you all. So our last speaker of the morning is a virtual presenter. I am happy to introduce Julie Jakubowski, who is here from Met Ocean Solutions and will be speaking remotely.
Cool. Thank you very much for the intro. So it is quite early in the morning here in New Zealand. I'm based in Raglan, New Zealand, which is a small town on the west coast of the North Island. And I'm here to talk about the Moana Project's Mango Pare temperature and depth sensor program in partnership with the fishing sector. I'm a physical oceanographer by training and am the team lead of one of the themes of the nationwide Moana Project. I'm going to see if I can minimize this. Okay, so the Moana Project is a 5-year New Zealand-wide oceanographic research program funded by the Ministry of Business, Innovation, and Employment. And the broad goal is to improve our understanding of ocean circulation, connectivity, and marine heat waves to support an enduring seafood sector through 4 research themes. One of those research themes is called Te Tira Moana, that translates to Eyes on the Ocean. And that includes applying the Internet of Things concept to achieve smart and sustained nationwide ocean observing capability. And that basically translates into the sensor program. So while there are other aspects of the Moana Project I could talk about, here I'm just going to focus on our Mango Pare sensor program. So Cooper showed a figure of Alaska and the gap between basically existing ocean observations and the coastal shelf regions. So this is our version of that figure. This is the average number of Argo profiles per day from 2007 to 2017 in the area where we provide a hydrodynamic ocean forecast and hindcast around New Zealand as part of the Moana Project. So the key thing here is that there's this coastal gap, again, as Cooper mentioned, happens worldwide. So the question for the Moana Project was, how can we incorporate untapped resources to fill this gap? New Zealand has a very large exclusive economic zone compared to our land area, and we have about 950 commercial fishing vessels active in the past year. And so if you look where those fishing events occur, it's basically exactly in that coastal gap. And I'm citing here a paper that by Cooper Van Rankin et al. That shows this worldwide pattern. So what the Moana Project decided to do is to work closely with the fishing sector to observe these coastal oceans, similar to the programs that have been talked about here so far. We decided to develop the Mango Pare temperature and depth sensor. And one of the key requirements was that there is no human intervention required for daily operations. So the sensor start and stop is triggered by a pressure change. So basically when the sensor is submerged in the water, and the entire data offload and transfer to the cloud process is fully automatic. That actually includes now our entire data pathway. So that's from the sensor to our ocean models, which I'll talk about in a bit. But the sensor was co-designed with the fishing sector by Zebratech, our technology partner, also based in New Zealand. So it's designed to be mounted on and withstand impact from a wide range of fishing gear. It's low cost, lightweight, and it has a battery life of 2 years, which is also when calibration needs to happen. So basically when this sensor is installed on fishing gear, nobody has to touch it for 2 years unless it gets damaged. But so far in the last 3 years of having sensors deployed, we've had about 6 to 10 sensors get damaged. The temperature accuracy is 0.1 degrees Celsius, but it's actually more like 0.02 degrees Celsius. And then the pressure accuracy is 0.5% of the full scale. So that's either of 200 meters or 1,000 meters. We have 2 sensors designed for different depth ranges. The deck unit is fully solar powered, so it doesn't need to be connected to the vessel power. We currently have cellular and vessel Wi-Fi versions developed. We're working on a satellite version, and that also provides GPS location for our sensor measurements, which we then correlate via timestamp to the measurements that the Mango Pare sensor is obtaining. And here's some pictures of the deck unit on the top right, and then the sensor on the bottom in its tough jacket designed to protect the sensor. So as I said, the data pathway is fully automatic. We mount the sensor on fishing gear. largely designed for commercial fishing gear. Once that gear is deployed, the sensor begins measuring as soon as it's submerged in the water, continues measuring temperature and pressure while the fishing gear is submerged. When it's retrieved to the vessel, the data is automatically offloaded via Bluetooth to the deck unit. So that solar deck unit is mounted somewhere on the vessel, and it transmits the data to the cloud via cellular or the vessel Wi-Fi. It arrives at the ZebraCheck cloud server, where we have a sensor and deck unit monitoring system to make sure everything's working correctly. That data then goes to the MetOcean cloud server, where we perform automatic quality control and data processing, and we also have a quality control monitoring system. Then the data is ingested into the MetOcean observations database, and from there we email the data back to the fishers in near real time. So currently that's within 3 hours of transmission from the vessel, but it honestly could be within 1 minute if we set it that way, but we just haven't gotten there yet. And then our modeling team pulls the data from the database into our hydrodynamic forecast and hindcasts, basically of temperature, salinity, current, velocity. And then those products are also accessible by both the fishers and the broader ocean community. So we quality control the data to international standards. We have fishing specific quality control. And as I said, the observations are provided back to the vessel that obtain them. In our program, the fishers actually own the IP of the data, so they decide what can be done with it. We have an agreement with them that we can use it for our purposes in our program, and then they can use it for whatever else they would like. And we also do not share their fishing positions unless the vessel gives us permission. This is the case in our program, but that's internationally, that's program dependent. And we're also looking at the GTS data pathway. That's a work in progress, and that's sharing the data on the global telecommunication system so that ocean modelers around the world can access the data in the case where the vessel is willing to share publicly. So this is the kind of thing we return to the vessels. So they get an automatic email with summary statistics from their deployment, a plot like the one below, and then a process CSV spreadsheet. So then they can do whatever they'd like with the information. So the plot has, you can see on the left here, depth on the vertical axis and time on the horizontal axis. So basically this is a sample deployment where the sensor went from the surface to about 17 meters depth and then was retrieved to the surface again. Temperature is shown in color. So we had the coldest temperatures at the surface here. And then they get a map on the right showing where those fishing activity occurred and the temperature in those locations. And then some statistics on the bottom. So this is actually a sample deployment by some students on an educational vessel called the Spirit of New Zealand. So this was developed with feedback from the fishing sector. We've gone through iterations of how to get the data back to them, and currently this is the one that they have found most useful. We're also looking at sharing the data through a data portal called FishServe here in New Zealand, which is where all the vessels are required to keep their catch data. So then they can look back in the future and just plot catch and temperature together. So here are some example data profiles. So we're working with 12 different commercial fishing gear types. Actually, I think I looked last night, I think that's 14 now, plus 4 different types not associated with commercial fishing. So these are things like research vessels, the education vessel I mentioned earlier, and some others. So what I want to show here is you can see the titles are various different types of commercial fishing, and we get all kinds of shapes of profiles. So this is interesting in that processing the data can be a little bit challenging. We have different processing for different scenarios, but it also means that we can talk to different vessels about joining the program depending on what kind of data we want. Mostly in the Moana project so far, we've just focused on getting nationwide coverage of our coastal seas while working with as many different types of fishing gear as we can as we were developing this program. But the potential is there to work with specific types of gear if needed for certain kinds of observing programs. Okay, so how has the rollout gone? So we started rolling out sensors in June of 2020, and we are now in January 2023. So here are some statistics from the 28th of November 2022, so about a month ago. The map on the right is the average number of Mango Pare deployments from June 2020 until the end of November. It's the average number per month. Darker colors are more deployments. So as you can see, we are really covering our coastal seas. We've achieved our objective of filling that coastal gap. And it's been really amazing to see this happen. So right now we have more than 30,000 profiles actually. So that's deployments. So 30,000 times 2, so we have about 60,000 profiles, more than 11 million measurements. Our deepest profile is 1,562 meters, despite the fact that the sensor is only rated to 1,000 meters depth currently. We're looking into potentially developing a deeper sensor for deep water longliners, essentially. And the combined time underwater is about 32 years. This is rapidly increasing now that we've finished our sensor rollout at the end of September. So we had 300 sensors to deploy that we could provide free of charge. We've now provided them on more than 200 vessels via a close partnership with the New Zealand fishing sector. It has been amazing working with the New Zealand fishing sector and working with the fishing companies in New Zealand. We have sensors on all 3 of the biggest New Zealand fishing companies, plus many others, independent fishers, research vessels, education vessels, industry vessels. And now we have 2 Waka Ama teams, which are Polynesian voyaging canoes, who deploy them during their training. So this could not have been done without that partnership. And I'll get a little bit into communication later, hopefully, if I have some time. So the vast majority of our vessels are commercial fishing vessels. We have some citizen science and research vessels as well. And this plot on the right here shows from June 2020 to October 2022, the number of Argo measurements, which I think has been covered. So Argo is a near real-time ocean observing system that is global and has been going on for years and has provided amazing coverage of temperature and salinity in the global ocean. But as I showed in that map, they are not designed primarily to observe coastal regions. So if you look at that map, that area around New Zealand where we are running our ocean models, this is the number of Argo measurements in orange and the number of Mango Pare measurements in blue in that region over time. So you can see that at the beginning of our deployment, we were right around the number of Argo measurements, and now the number of Mango Pare measurements is just skyrocketing. So what are we doing with the data? We ingest them into our Moana Project ocean models. So we create a marine heat wave forecast that's 7 days in the future around New Zealand. That's what I'm showing here on the right. And you can go on the moanaproject.org website to look at those marine heat wave forecasts. It's really exciting. We've had quite a bit of news coverage on it, and the fishing community also is using those. And we also have a 25-year hindcast, which looks at the picture of the ocean the last 25 years of temperature, salinity, current velocity from the surface to the ocean bottom. So our 7-day forecast also provides a forecast of ocean bottom temperatures and temperatures at various depths within the water column. So our fishers that participate in the program, and actually the general public, can go on the Swell Map website and get forecasts of ocean temperature below the surface. And so really quickly, here's an application of marine heat wave science that's been done. So this was Dr. Rob Smith at University of Otago, and he looked at this region off the west coast of the South Island, where they're having, I think, the strongest marine heat wave they've ever had, and it's really impacting crayfishing. So this top figure is the temperature from the Mango Pare sensors from the surface to 200 meters depth over October to April of 2021. And the bottom is the Cicero Carr's Austate climatology. And so this is what normally would be used to look at subsurface temperature. And you can see that the actual observations from Mango Pare are much warmer below the surface during this marine heat wave here than you would see at the surface, or that you would see using the climatology. So it's really important that we have these measurements to understand marine heat waves. And then my last thing is communication and co-design has been absolutely critical to this program. So our team made more than 500 phone calls to vessels to explain the program to them, to find out what their concerns would be, to talk about joining the program. And now we're in a phase where we're getting feedback to make sure that this program is basically the best program it can be for the fishers. And so it's been interesting to see how vessels are starting to use the data, how fishing companies are starting to use the data, and we're really looking forward to seeing where that goes and to what we can do together in the future. So I think my time is up. So I will skip the benefits and impact slide. I think most people here understand that. But please ask me any questions. I'm happy to chat about it later. And then thank you to everybody involved. It is a huge effort with a lot of vessels, a lot of organizations, and it's been fantastic to have their participation and their support of the program. Yeah, and thank you for having me here. I really wish I could be in person at WHOI right now. I think this is an amazing effort, and yeah, thank you for being here.
Thank you very much, Julie. Hopefully you can hear me. We have time for one question before lunch, or perhaps if you want to stay and hang out, but it is lunch coming up soon, so at least here in the U.S. East Coast. So we have time for one question.
Hi, Julie. I'm Linus from Oregon State. Thank you so much for your talk. It was really interesting to learn more about the Moana project, which I've heard a lot of, but this is the most information I've got about it. I was curious, unlike other projects here on in the U.S., where it seems like personnel, it seems to be a challenge with staffing and managing such a large project. About how many folks do you have on the project management side of things to, collect this data at such an impressive and awesome scale?
Actually, I should calculate that number. So the Moana project overall has about 65 researchers on it, but that is not just the sensor program. I really wish we could talk about all the rest of the things that are going on because it's really cool. But I think our team is about 6 to 8 if you include people who are being paid directly by the Moana project. They're definitely not all full-time on the sensor program. Some of us are. And then I don't know how I'd even calculate if you include the time the fishing sector's put in. It's just been amazing. Yeah, so hopefully that kind of answers the question. It's a good exercise. We should go through and figure out actually how many hours are being put into this.
Great, thank you very much, Julie. And please join me in giving a round of thanks again to all of our speakers for this morning session.
All right, everybody. Welcome to the afternoon of day one here. My name is Dave. I'm the director of the Commercial Fisheries Research Foundation. You heard about our organization from talks with Aubrey and Noel earlier. So with that, I'm really grateful that we have fishermen from the projects that were talked about earlier this morning to give their perspectives and answer some of the questions that have been already asked. So often, maybe all the times in meetings like this, we have to speak like we did this morning on behalf of what the potential benefits and uses are. And now there's an opportunity today to actually have the people that are collecting the data and using it potentially to talk about their perspectives. So with that, I think if you could just say who you are, what program you're a part of, and then just briefly kind of the pros and cons of your experience, and then how you're using the data that's collected if you are using it. I think that's our question that was already asked, and then we'll open it up to kind of a Q&A for most of this.
Well, you want to start at the other end.
All right, I can do that. Jay?
They got something serious.
They're making fun of me for the candy. You have to start.
Okay. How's that for getting thrown under the bus?
Okay. Hi, my name is Jay Swoboda. I've been fishing out of Point Judith on a full-time scale for 40 years and 14 years before that. I fish, my boat's name is the Karen Ann. I'm an inshore lobster fisherman. I fish by myself. I fish 450 pots, 3 days of 150 apiece. And I've been in the Ondeck data program for 8 years. And as I'm getting towards the twilight of my career, I feel it's really important to give back to the fishery that's been so good to me. The Ondeck data program fills a lot of holes, like you heard this morning, but for me, it's essential to get the data, especially in the winter, when nymphs may not have some, lobster and crab data. So even just putting a 1 down is better than a 0. So it's very difficult now to go in the winter because of the closed area, South Shore Island's closed area, which, if I can leave one lasting impression on any fisheries program that used fixed gear for data collection, start working on your exempted fisheries permit. I had a 8-year streak of my temperature logger being in the same place 365 days a year. I just switch pots, bring a clean trawl out, and bring a clean one out, take a dirty one home, take the logger out of it, and put it in the clean trawl. I can't do that anymore, although I'm working on it with some ropeless exempted stuff going on. But that's anything that has a database to it for research. You really need to be on that exempted fisheries permit. Over the years working with Aubrey, we developed a Bluetooth transmitter to go on the calipers to transmit the data right as you're measuring it to the tablet. And from what you all know, developing stuff that took probably 3 years to get it flawless, but now it is flawless and it works really good. So that's about it. I'd be happy afterwards to answer any questions on the inner workings of stuff. But with that, I'll hand it over to Mike Marchetti.
Thank you, Jay. Mike Marchetti. I actually, Jay was one of my first captains I worked for a long time ago in the early 80s.
Feeling old.
Still a youngster in high school. And yeah, so anyhow, been fishing since almost 40 years now myself, and just fishing on up through scalping. I'm currently scalping. I go year round. I was a lobsterman basically for 35 years as well. I started out with Jim Manning with his probes, and the DM had a similar probe right back in the 90s, mid-90s if I remember correctly. And I've always been interested and curious. I worked with Anna and the Ocean Stamp when we were forming the Ocean Stamp. Did that, and I got to do a lot of live feed camera work. And every time I get involved with this stuff in these projects, I get more questions. That's what I love about it, actually. I'm more and more curious. I wonder why the hell I ever caught anything right there after I do anything. But to the temperature probes, I work with CFRF as well as Jim Manning, and again, I've done aquaculture also, kelp farming and mussel farming. Again, that lends itself to more interest, more questions about chlorophyll, constantly questions about dissolved oxygen, water temperatures, what are the mussels doing, why are they doing that? Well, temperature, and when's the best time for feed and growing, and same thing with the kelp. And then I try to apply that to scallops. Why are they here and why are they not there? And I used to do that with lobsters, I used to put little thermometers in glass jars and read them. Space them out all over the area and read them and try to zero in on an area, I think it all helped. And as these programs and technology developed, it was really kind of cool. And I kept getting into the next thing. I have the Moana probe now. I've had the Aquatech. I've had the Lowell. And my thing now, several years ago, it was bycatch. We don't seem to get much bycatch now the last couple of years. I don't know what's going on, but working with Glenn through Shell Fleet and everything and seeing his work, and again with Jim, more questions, some answers, and okay, what's going on with my scallops near shore? I'm an inshore guy, okay, small boat, and like the other day, I went and scrolled through trying to figure out, are the meat yields changed? I think they are. What's the water temperature doing? And again, I was interested in, well, how about the brill? How about the fluke? How about the yellowtail? Trying to find some correlations to that. So I I'd say I'd use it. It's still a curiosity. I haven't figured out how to use it directly, because at the end of the day, you still got to set it in, haul it back, and see what you got on deck. See if it's happy or not happy, and go from there, you know? You still got to fish like a fisherman. But it's another piece of the puzzle. Maybe it's a dangling carrot for me. I'll admit I got the attention span of a young cat. And I'll chase after these things, but I often say I won't live long enough to mess with all the things I want to mess with in this industry, quite honestly. So I'm happy to participate.
Hi, I'm Rodman Sykes. I own a 68-foot dragger out of Point Judith, Rhode Island. And I've been in the business for 52 years. And I've seen a lot of things happen like these guys. And I think, like Jay said, I'm hopefully at the twilight of my career too, because it's getting to that point. But I've always been interested in temperatures ever since I was a kid, sword fishing with my uncle. And he would get a bucket of, take the deck hose, get a bucket of water and stick a thermometer. He got the hardware store in there, and try to make something of it. And for many years with my dragger, I did a lot of tuna fishing, and we would get the temperature reports from NOAA that would help us know where to go. I've had Jim Manning's equipment on a boat for, I don't know, 15 years probably, and starting to try to learn something about the bottom temperatures, which we don't know. As I say, by the time we figure out what it means and what it can do for us, I'll probably be long gone anyway, but at least it'll be something that can help the future. I've also worked with the study fleet ever since they started that back, I don't know, at least 15 years ago. And I have the electronic monitoring cameras on the boat. So they're watching us from all directions. We can't get away with anything. So one of the things, as far as doing all this cooperative research that I found is important to the guys is getting the crew to buy into it. The guys that help me actually do the work, because some of that is a lot of extra work for the crew, especially the electronic monitoring, which having to pick up the discards and measure them under the cameras and things like that. And my crew, I have well, to give you an idea, the average age on my boat is 68 years old. So these guys have been in the business for over 40 years, both of my crew and two. So they understand that they're not going to be around much longer, but to maybe do something for the future, for the guys in the future. And I've always said to the guys and also my fellow fishermen, you know, you complain about what they come up with, but if they ask you for help, why don't you just help them? And we do get some of them agree with that and come and help us, like these guys here. So I don't know how much longer I'll be in the business. My boat's for sale now, but I am going to continue to do what I've been doing and anything I would say that they ask me to, because one of the other things is that, you know, when you guys have done it, but dragging can get kind of boring at times. And this gives you a little something interesting more to pay attention to and actually, you know, make it a little more worth it, that you're actually doing something worthwhile. So, next.
I'm Jim Barkley. I'm from Harpswell, Maine. I'm a lobsterman. I've been doing it for 40 years. That goes by quick. I have a temperature probe, EMOLT probe in my trap, and I look forward to hauling it time to get around to it, because it makes a difference. I swear by it. I have had it in the same spot for over 6 years. I keep, like he did, I keep rotating it out, put it in the same spot. The only difference I've seen in water temperature is I used to go shrimping in the winter times, and there's no more shrimp. They're gone up in the Gulf of Maine. So I go lobstering year round, but that's the only difference I see in water temperatures. The shrimp disappeared.
And, yep. Here you go, Dave.
Well, we're out of time. Well, I'm Dave Cassoni. I'm the Secretary Treasurer for the Mass Lobstermen's Association. I'm a commercial lobsterman in Sandwich and Cape Cod Bay. And I'm really pleased to hear that there are guys that have been fishing more than 50 years sitting up here, because I thought I was the only one anyway. But back in the dark ages, which we will have to go to, fishermen were very reluctant to do anything as far as science went. And when I first was approached by Jim back in the Cretaceous area, I think, or something, my job was to be a facilitator to try to get fishermen to participate in something as simple as temperature probes. We all, and I'm glad to hear you guys, we all put thermometers in jars and dropped them down. We tried everything. We thought there was a correlation between the temperature and our lobster catch, especially lobsters. We realized that, you know, a recorder will show finfish and everything else, but right now we can, you know, I'll text the lobsters so I tell them where I'm going to be. But years ago, we had to guess, and we always thought it might be temperature related, and the emote was the first, and it really started. And since then, we've actually gotten an awful lot of interest in a lot of other things. We've had cameras on the bottom. We've had dissolved oxygen recently, and we're getting more and more lobstermen involved. I'm very happy. 40 years ago, if we'd have thought we could plan a meeting like this, where there would have been the scientists and the fishermen, there would have been 2 or 3 fishermen, and there would have been a lot of scientists. And one of the biggest reasons that fishermen were reluctant was, no matter what we did, if we made some type of scientific information, the managers would get a hold of it and would come back and bite us in the ass. And we always were afraid of that, and it has changed. And as the times have changed, I'm really glad that I am participating still in something like this, and that it has grown into something like this. And it is so important that science and the fishing work together. We realize the managers are always sitting there. We know that, and it's going to happen regardless. But ours is, does it improve our catch? Does it make us more efficient? I hope so. You know, maybe, maybe not. We always like to think, as a lobsterman, we're trying to outsmart an animal with no brain, and it's bad for our ego. So we'll do anything in our power, and this is one. And I'm so pleased that this has materialized. And I'd like to, I know that there's an awful lot, and it always boils down to, gee, wish we had more funding. Well, there's a lot of funding has been saved as a result of the fishing community participating actively, let me tell you. Thank you.
Thank you. Thank you all very much. So the point of this part of the meeting is for the people that have questions, for the end users, the people that are actually on the water using these products. You know, now's the time to ask them. There were many questions this morning that would be relevant again to ask. So if you want to ask it again, that's great. Or George and I can kind of paraphrase those questions. And I would also say, you know, the other participants in the room, just because you're not on the panel doesn't mean you can't chime in and give your thoughts as well. So please, if the other fishermen that are part of these projects have an opinion, you know, feel free to answer the questions too.
Hello. Thanks everyone for being here. I really appreciate the experience you guys bring. So I work in the Gulf of Mexico, and we have a very small monitoring project. You saw me give a short presentation. And something that we've tried to provide is value-added feedback to the fishermen for their use and in their fishing operations. So I'm curious, from your experience, what's the barriers to using this information and like what you do, but also is there a little bit of homework that needs to be done by you to understand like what this information means? And I ask that because I provided some sort of like guidelines for our, you know, our fishermen with like, this is what like typical oceanographic parameters would kind of, we'd expect, or this could mean a certain, be interpreted a certain way. I just would just value you guys' feedback on that.
Anything that I give to the foundation, they're free to use. Fishing 54 years, I don't have any secrets. And I don't think I've ever set a lobster pot where somebody hasn't set one before me. The hardest thing about lobstering is knowing where not to put your pots so you don't get towed up. So if it can help in the future, you already saw my temperature data this morning in that overlay. The world's a better place if they can gain any information, you know, from me.
You know, yeah, I've like I said, I work with CFRF and Glenn with their the shell fleet, and John and George here. And one of the things I got to say with data is having it right up front so you can see it. One of the things I really liked was when I had the Aquatech, and I had a Lowell too. When things would pop right up in front of my face, I have the study. I also do the real-time reporting every tow for the cooperative research. Vaping on words, sorry, Anna. Yeah, so I do that also, and I liked it when it popped up on my screen. One thing I've noticed with the Raspberry is visibility. You know, I have to wear glasses now every once in a while. But you know, a small screen and just accessing the data you want, because you get something pops in your head right now, like, geez, what's going on? Because something looks a little different here, you know, and you know, like maybe the meats look a little better and looks like they're coming out of spawn or something for scallops. And I go in, so I want to be able to access that. With the Aquatech, it popped up on my 13-inch laptop screen and it was right there. And I could see it every tow and be peer over. And sometimes I was impressed enough to take a picture of it, you know. And so having it up front and keep it simple, sailor, is all you know. I mean, I keep saying I want to see this, I want to see all these other things, but yet it has to be simple and it has to be nearly immediate. You know, those two things I think are really important, because you're thinking of something, you want it right then. You're busy. I'm scatterbrained. I'm trying to focus on working. I don't want to have to punch a little tiny buttons and stuff like that. I can't. But simple and direct and immediate. I mean, we all have it right here every day. I guess that's something we've become accustomed
to. I know the information's always available to us. I really haven't used it that much because I still keep a paper log, and I write down the water temperature every day that I fish. And so it's right there in front of me. You know, probably for the last 20 years, I've got that information. I got where I towed and what I caught right in the book in front of me. But I know there's a way to get into that computer and see what I just don't know how to do it. Get the same information. But it's nice to know what's there if I need it, and you know they'll go get it for me, and hopefully share it with whoever needs it.
Why not? Your system works because in the Gulf of Mexico. You were working with a red tide, which was a trigger, and it showed the catch so that they could make a correlation. With us, one of the biggest things in the world of lobster is we've always related or thought that the lobsters were triggered by that bottom temperature. Hence, we wanted to know it in real time is critical. One of the things that I've found that has been probably more valuable to me than knowing what the bottom temperature was a month ago. I don't have a real time on mine. I have a logger, and that people are constantly asking me as a fisherman, has the ocean temperature changed? Because the media has put out global warming, where obviously we're boiling in the ocean. There's got to be a big problem. And we can pretty much accurately give them information based on multiple years of bottom temperature studies over a period of time. And now with all of the rest of that information, the public gets a much more accurate, at least from our perspective as fishermen, of the condition of the ocean. We're asked that all the time. I'm sure all of us are.
Give it back to me.
You can use the ones in front of you. You don't
Oh,
have to pass it down.
no, that's dangerous.
Other questions?
Hi, thanks for sharing your experience. Some of you mentioned why you got involved with this. So I wanted to hear, how do we get new guys invested in this kind of partnership? And a second question, what's your wish list of information that you wish you had that we don't have the capacity for now?
Yeah, go ahead. Somebody else? Ready.
One of the things you know, Jay, I like seeing the presentations, and right off the bat, you know, I think it was Tracy put one out, you know, with their temperature, depth, and DO. It's like, boy, how can I get a hold of that tool? You know, one of the things I'm trying to, again, piece together things, maybe the wrong puzzle pieces, but I was curious, what's the food like down there? Is there chlorophyll down there? I did that with Nixon and Granger once, you know, the correlation, yeah, so a study for that anyways. And we, again, questions and more tools, and those are things that I'd like to see. Getting guys interested, you're gonna have to find buy-in. Like with the Flounders program, bycatch reporting, and getting over the idea of being tracked and traced. Most of us have VMSs anyhow. I mean, there's no secrets anymore with some things. Right, a little bit, but, you know, from the other guy, I mean, you know, but you gotta get past that and realize that in a lot of ways, it's been said here already, it's for your protection. And one of the ways that we're seeing it is trying to work with, and in some cases against, windmill companies. You need your own information, actually. You need access to your own information even. You know, so a lot of fisheries already have that, but not all do, such as, you know, up here, lobster and crab. So that might be one aspect of buy-in. You're getting guys to say, hey, you know, it does help you. Really, at the end of the day, you guys got to realize if it helps them or not, and that's where they'll get buy-in. If it doesn't help them, you're just not going to get them to participate. You know, I thought it would help me. I don't know, and somebody next to me says, yeah, I can see where you're going with that. I don't know.
See, I think mostly you have to show guys that it does help them, or at least where their information is going, and if it's being used properly. I've tried to recruit people into the study fleet, friends of mine, and some jump on it, and it actually is extra work, a little bit of extra work, but if you tell them, well, one thing you can tell them, it's not the study fleet, but the electronic monitoring with the cameras on the boat eliminates observers, not totally, but a lot less observer coverage because you're showing them what you're doing on your own. And that's something that isn't, I think, at least with me, was a big selling point. And little benefits like that. It is a lot of extra work, we pick up sometimes 150, 200 extra fish in a tow just to put them under the camera and show them the discards. But so it can be a lot of work, but in the long run, it's well worth it to me to do it ourselves, you know. If you don't trust Henry Bigelow, John Chafee, and them, you don't trust what they're doing, you don't like what they're doing, do it yourself. And you got faith in the information that's going in. Right? I think so.
Yeah, I'm probably the furthest one up in Maine with the emo, and Aaron, there's a couple guys that want to do it, so they just, you know, they got to find the time to do it. And like he said, we got something big going on from here all the way up the 3 mile line. I'll be on the 12-mile line all the way to Nova Scotia with windmills. It just came out Thursday, and you'll probably be seeing it on the news soon. I got it on my phone.
Yeah, that's going to be our biggest issue.
All right. You got me again. First of all, it's very difficult to get young people into the industry. This is a kid right here looking at this table.
Yeah.
All right? And that's what we face. We do have young people. We try very hard to not only get them involved in the industry, but to get them involved in the research and the science, because it may be something that's going to come back and help them. The dissolved oxygen that we faced in Cape Cod Bay was important. When you're talking to people like the lobster industry in New England, we are facing more than the temperature change or the dissolved oxygen. We have the right whale problem. We have the wind farms that are coming. Both of those present different entry questions to young people. And then on top of that, trying to convince them to participate in an industry, it's very difficult all the way down the line for all of the fisheries. So we can only hope. We do have some young people, and we browbeat them as to the importance of doing this work collectively.
I think, to get back to your original question, what I would like to see is I would like to see, in my case, my tablet acquire GPS fairly quickly. I'd like to have a hands-free connection. I'd just like to leave that temperature probe in the pot and have it be read and be able to look at it, because I do. As soon as that goes to done, I'm on view right away, because I want to know what that temperature is on the bottom. Now, that being said, it doesn't. When I first started in the foundation, it was like 2 years in a row, temperature went up. The last week in September, I started catching lobsters, and it was like, I'm a believer. I'm in full speed. And it's pretty much been that way for the 7 or 8 years catching lobsters. But I think there's more going on the bottom. I want to know what triggers sheds. I want to know why they'll just stop. I mean, the tide, could be the moon, could be oxygen. I mean, we just don't know. That's what I hope to spend the rest of my career answering these questions, curiosities that I have. And to get guys into it, I got into it because I wanted my data used stock assessments. You're not catching any lobsters. We're going to have to take drastic measures. They talked about a 5-year moratorium in southern New England. And catching lobsters now, not catching them like we used to, but what we're putting into the stock assessment at least shows there's something really important. And sort of drilling the young guys that this is the future.
I add to the wish list thing too, and it is a double-edged sword. What young guides though is one comment, but how to tell them that this is important for your survival going forward, the future generations. And the double-edged sword, I wish we had better connectivity on the boats. Certain projects I've been involved with, well, we can't link up till we're up inside somewhere. Cell service is horrible. I say it's a double-edged sword because the last thing you want is your friggin' crew sitting there. A lot of guys, I had some guys I would deliberately go to places where I'd try to find where they had no service. Or if I found that line, I would go across the line, let their phones all ding that they had messages, and turn around. Nothing, just to drive them all nuts. But in the wheelhouse, connectivity will be a bonus, and I think.
But to that extent, there's projects that you all are doing that could easily be sold to the cloud. temperature, if it's an inshore boat, it's home every night. So it's gonna go dead for 10 hours, 12 hours, then it's gonna have service again. Some projects, the future of ropeless fishing, are gonna depend on real-time, instantaneous transmission of data to and from receivers and users. So I think you have to make your priorities where cellular service is going to make do and not incur a lot of expense in satellite transmission.
I'm just going to ask a quick question as well, but also just want to make sure that the other industry in the room have a chance to chime in or introduce themselves, because there's definitely a lot of knowledge in this room besides just the panelists. I don't just want to make sure I give everyone a chance. But the question I have as well is about talking to many fishermen that I've worked with. They've always kind of talked about this Dream website or a Dream app that they could, before they leave the dock, look at and know the temperature in the area or the salinity or the dissolved oxygen. And I just kind of wanted to hear your perspectives on kind of what would be useful for you. Is it something that you want before you even leave the dock? Or kind of, I think that's something with a lot of technology and sensor companies in the room would be really valuable to hear your insight on.
I'll just admit, I don't know what I'm looking for when it comes to after you get above temperature. I mean, I know that temperature kind of works. And, that's when I really keep bait, and it means going and getting beat up to put bait in the pots. I'm going to go those weeks because I know I'm going to get rewarded. But there's something else that triggers all this stuff, and hope I have time to find out. That's
Jim would remember, sorry, he would remember, and jog my memory, maybe George or Dave, there's a group down in South County that you had a website that a lot of that information was put on that you told us we could access. And I long since stopped trying because it wasn't very user friendly, and I'm not the most handiest. I'm not a computer generation. But, that's one of those things, like Aubrey, you asked that. Yes, that would be great if I could look at some of that stuff and say, maybe I should be going this way instead of that way. That would be great, but it's, again, simple and user-friendly type of stuff. And I'm sorry, I'm blanking on some of my important points there, Jim. I can't remember what that app was that you had right now.
Hi, Jim Moore, Alaska Trollers Association. And I'm shocked to find out someone has been fishing longer than I have. 53 years here.
So the first year was non-commercial, so that was only 5 pots.
But I thought that I would share something with you, if you'll indulge me here a little bit. I wrote a little piece for our journal, for our association, an update on the our attempts to get the an electronic logbook program launched. Since this time, we got funding and we're on a roll. It's developing beautifully. I have also been using some of these instruments for the last couple of years. I had the privilege of towing around one of the Moana instruments that Cooper and Jack set me up with, and the way it's set up, I have access to the data immediately. It presents the whole water column, and I found it useful. The other is we're doing CPD casts for the university, as I said earlier, and with the Ruskin app, we get a nice graphic display of that data immediately too. So that's where it's most useful. But anyway, a part of this little article I thought relates to what we've been talking about today. I'm writing this to my fleet. What are the benefits to our fleet from our developing and participating in this project? Here are some of my thoughts. I think a good troller, and you could substitute fisherman, is a natural scientist. We seek to understand what goes on in a realm mostly hidden from our natural senses. You know, where are the fish? Why are they there? Is it structure? Are they feeding, migrating? What are they feeding on? What kind of gear is most effective? What is the tide doing? When is the bite? How deep should I set my gear? How fast should I troll? We discover the answers to those questions mostly by observation, experimentation, educated intuition. And when we get it right, we're rewarded by a nice catch at the end of the day. That's applied science. And like the scientists, we build our working knowledge of our fishery not only on our own experience, but also on the discoveries of others. We, at least some of us, benefit from working together to be more effective. The seasons, especially Chinook these days, are just too short. In recent years, especially, as I'm working alone, as I like to do, I'm just beginning to get dialed in when it's time to quit. And every season is so different, but there seems to be patterns that repeat, and sometimes you can recognize them, and well, you get the idea. I've had the privilege of knowing and fishing alongside some of the most renowned trollers of years gone by, and most of the legends about their amazing canny are true. I don't expect there will ever be better trollers because they fished entire seasons when and where they wanted and built an amazing intuitive connection with the ocean. Can we ever approach that kind of wisdom with present management of our ocean Chinook fisheries, directing our efforts away from the most productive times and areas with our 6-day seasons and 3-day openings, and no fishing in areas of high abundance? Perhaps not, but we do have GPS and Bathy charts and satellite imagery and access to big picture science, which our predecessors didn't have. And with all of this emerges whole new sets of unanswered questions about the fishery and about the sea, questions that can only be solved by educated intuition, aided by lots of good data and technology. Just as it's our job to make those discoveries that increase our understanding of what's really happening beneath the surface, to increase our production, it's the job of the scientists, oceanographers, fisheries biologists, to gain a better understanding of how the marine environment works, the dynamics of an ever-changing ecosystem, the effects of changing climate conditions on fisheries. Here our interests converge. The better the science, knowledge based on reality, the healthier the relationship between fisheries and managers. A poor handle on stock assessment, for example, must lead to precautionary management. When the forecasting models are based on data that's too thin or otherwise unreliable, they fail to be accurate. Mix in a little politics and it's a real mess. How is a Pacific Salmon Treaty fishery scientist like an artist? They're both in danger of falling in love with their models. There's nothing wrong with using technology to generate models of ocean ecosystems and biological and physical trends. The problem is that ocean data for Southeast Alaska is too thin, in many important aspects practically non-existent, to produce reliable results. Our fleet could collectively help address that problem by providing a research platform to collect data useful for managers and scientists, as well as for us fishers, through resurrecting the ATA logbook program in an electronic format. This would provide near real-time data on catch for managers. Through a daily logbook entry on an iPad, catch data would be integrated with location and some simple observations to provide permanent personal record for the individual fisherman. The combined entries from the fleet would provide useful data for oceanographers and marine biologists that would otherwise be unattainable at any cost. That's as much as I'll read, but I think you get the idea.
Thank you for sharing that, your perspective. We did have an online question, so let me just engage them real quick. So from the internet, says, is there interest in understanding lobster, shrimp, mussel dynamics in association with changes beyond temperature. These systems are undergoing a number of changes, including acidification and hypoxia. Temperature plays a factor, but there's a lot else going on. So I think kind of talked about that a little bit, but there are any other key parameters you're looking for besides temperature that maybe we haven't talked about yet, or you just want to expand on what you look for?
Really, I mean, you know, temperature, depth, and conductivity, pH, you know, and dissolved oxygen. I think are the big ones in my book right now. I open my mind to think beyond that much, to be honest with you. Where can we stop? Let's bring it, you know. You know, Dave, you've been involved in scallop management, and you've seen it, and anybody else that's been involved in the council process, you know, all that we can do to answer these questions helps better us make better management decisions. You know, and I wonder, I look at the work that Glenn has done through CFRF and the study fleet and all, and sometimes I see correlations to stuff that he's shown us in presentation that you guys have put on, Dave and Aubrey, and like, wow, that lines up awful conspicuously good with what's going on at, let's say, the Lightship South Deep or something like that, you know. And I think there's a lot that can be learned. Where do we stop? I think we got to keep coming up with good ideas and keep it up being scientists as well as fishermen.
Thank you. My name is Hassan Mustafid. I am with the Integrated Ocean Observance System based in Washington, D.C., sitting with the National Oceanic Atmospheric Administration, and thank you for the invitation again. So a couple of things. One thing is that we've been asking you how you can help science. The other question that I would like to ask is what you want from scientists to help you. That's the first thing. The second thing is that, as you know, that we take this data and integrate it with other data from fisheries, data from observance system, and we integrate it and we try to develop models to forecast and forecast these parameters. That's a good product, of course, for anyone who's doing operation in the ocean. But my question is that when you see, now not the physics forecast, you see that some products are trying to do forecasting of the creatures themselves, like lobster or some other fish or other things that moves as well. When you see that product, how you feel? Is that something useful, or it is just not? It's hard to understand. I know that they come with their uncertainties and all that challenge, but how you feel when you see telling you, okay, tomorrow things are going to be bright or whatever, or maybe not. So those are a couple of things I want to ask. First one is, what do you think what you want from these scientists around here? I think there are many scientists around here. They also want to know what kind of product, what kind of things you want from them to help you.
Okay. Well, one of the things, some of the information that comes back is overwhelming. Fishermen are based upon, we've got to go out, we've got to catch something, however we do it, either by trap, by net, by drag, by rack or gill nets, whatever. Our job is to find them, to harvest them, and to bring them back. Now, there are an awful lot of projects that will help us, temperature, maybe the pressure, certainly things in my area of Cape Cod Bay, dissolved oxygen and stuff. But we know that our product that we're trying to harvest reacts to the extremes. We know that when the temperature gets extreme, they're gone, or too cold, they're not active, or they're gone, or the oxygen level goes down. How can we can't predict, but we might be able to get a little better understanding of certain trigger mechanisms that might assist us in everything that's going to go about us trying to harvest that product. What can we be told that, I'm not trying to make everybody meteorologists and tell us the long-range forecast. That's tough. So trying to tell us where the fish will be, where the lobsters will be, is going to be even harder. But trying to correlate some of this and put it into some type of a working format for the average fisherman, again, we're lucky we've got cell phones up to date. We probably were introduced to the bag phone and then the flip phone, and probably myself included, reluctantly just gave up the flip phone. So we're looking for not answers, but maybe a little help in that meteorological prediction factor. We know now, looking at our dissolved oxygen in the bay, we see it real time, we can get it, we've got it. Does that mean I'm going to pick up all my gear and move it at once? No, that doesn't happen. But we know that some areas are going to be affected. Temperature, dissolved oxygen, I'm sure, salinity, pressure, chemicals, everything else. I don't know where anybody could do it other than an obvious red tide tells me there's going to be a problem. There are very few things that are that obvious in the triggers. Maybe I'm wrong.
You know, if I can jump in, I am more interested actually in the long term in the models, because I want to know, again, back to scallop management and looking at things, what is potential for juvenile settlement and long-term survivability? Are we going to see something come back down the southern area off of Jersey and the Delmarva, or are we going to see something that, is it going to stay up towards Georges? And I'm convinced that this also will apply and can apply to lobster, and how things will come around juvenile lobsters. Are they going to come around the Cape or how things move? But I actually would be interested in the potential long-term predictions and the potential survivability in where things are going to settle. And that would aid management, I think. Again, I've been on the AP for 20 years now, and more recently, and the more I get involved with this and seeing Glenn's presentations and working with Jim and George, seeing survey results and being, geez, you know, I wonder. I just keep saying, I wonder. And that's where I think these can potentially be of use. Potentially. It's going to take I'm not a fan of models, but at the same time, if you keep working at it, sooner or later, you might get it.
I really don't know what I want. If I'm going to get data, I would like to have access to it right away, so I can maybe find a correlation in either the history of my fishing that I've done, or what I've heard other guys have done, or what I see, my observations for that day, so I can start putting something together. But I don't know about oxygen or CO2 or whatever is in the water until somebody tells me about it. You guys are just learning about it, so I obviously couldn't have tested it. So we know about temperature, because that's what we've been doing for 50 years, you know, and we've got correlations with those. And some guys like Rodman may never look in that book because he's got enough experience. He doesn't need that extra information. He knows where he's going to go, you know. Other guys will always look for something to give us an edge.
Because I heard some interesting thing, and I think you brought up the meteor. And, you know, back in the time, we go outside, we snow, but today we can predict it. We predict it even for a month or whatever, I mean, with uncertainties that you know. We achieved that, but we achieved it with a lot of, you know, challenges and data and all that information. And then I'm hearing climate and changes. Very good point, because that's the thing, is that the processors now are up in the Maine, but they used to be in Long Island, years ago. Now, if things back then again, you're going to bring again the processors down there. Of course, you are going to start, you know, that kind of long-term you know, what you can expect in the future. But that's very hard. That's the tough one. Maybe tomorrow I can figure out the bottom temperature may be like this. But I think to go far in the seasonal or annual or inter-annual, we're trying to figure, I mean, some of this, we have plans, we have all this. But I think what I was asking you is that when you see now a forecast of a daily, let's say forecast for tomorrow, like we do with the weather, is that something that you can embrace? You can feel that, yeah, I can use that information to be able to go to put my pots or not. I think that's a challenging one. I feel like every time was back and forth with the industry. But thank you very much, because I think those are good points. One is short term, the long one, long term. The forecast is very challenging. Thank you.
I'll just add that with lobsters, before they reach minimum size maturity to harvest, they're 8 years old. So it's a long-lived fishery that has a lot of variables along the way that would have to go into some kind of long-range forecasting. I you know, natural predation on them when they're small. I kind of hope we're reaching an equilibrium in southern New England, but I don't have anything to prove that as far as the number of sea bass and the year of the young lobsters down here, because I can remember, and I could find it in my logbooks, just being inundated with sea bass that would be vomiting little lobsters probably 8 years ago, 9 years ago. So you just think that that would be really, you'd have to have an unbelievable model to take in all the variables to go that long term on lobsters. Short-term fishery, you know, short lifespan fishery would be a lot easier and much more predictable. Squid.
David, Jim, do you have a comment for that?
Oh, no, I was just asking him if he was seeing the sea bass up in Maine now. And that's a big problem. It is. And one of the things that we look for, like you say, it's 8 years of a life before we can harvest that animal, and a lot takes place. So it may not be the prediction of tomorrow, next week, or anything. It's the future. We have to know, and we do. We have now a lot of information on the circulation, the surface, because the plankton mass and then the settlement of the juvenile lobsters and everything else. We know that. We've got a lot of information on that now, but the things are maybe when they do settle, what are the conditions? Are they going to be favorable to remain there? Or are we going to have a problem if they aren't? And, you know, they have, the settlement occurs when they reach a maturation of about that 8 weeks, 4 or 5 sheds into it, where they're heavy enough to drop to the bottom, lobsters. And now you're the same thing with the scallops. You're looking at the bottom in the settlement from the surface, from the plankton. What is that? And what are the conditions over a period of time there? So we put our equipment out while we're harvesting, not in that, what is it going to be like 8 years from now there? So we like to hope. You broke it.
How about now? Oh, boy. Yikes. Too much Anna. All right, I have a question about capacity. So I feel like in many of our cooperative research programs that we heard about today, we are asking a lot of you all who are fishermen. Your jobs are to fish, as Dave said, to go find those fish, bring those fish in, and sell those fish. We are working together towards a greater goal of better understanding the oceans, but that requires us to put a lot of stuff on your boats and to come visit you when you're in port, or sometimes to spend more time in port so we can fix those systems. So my question for you is, at what point does it become necessary for there to be compensation? We haven't talked at all about compensation today. From my perspective, that's a really critical piece of cooperative research and is required in some circumstances. And so my question for all of you, and I'd really like to hear from other industry members in the room too, is at what point in a research program do you feel like there's some level of compensation required because of the time that you all put into it, which ultimately is time away from fishing and time away from your jobs that feeds your family. So at what level in these programs do you feel like compensation should become part of the conversation or the picture? Thank you.
Well, I could say right away that initially it would help. Trying to motivate someone to put equipment on to do something is getting harder and harder. Again, comes back to, is this something that's going to affect me because of management practices later on? But at the same time, we don't want everyone to feel that the only way they're going to do this is to be compensated. There might be something, some kind of adjustment to them initially to get them motivated. And then maybe after a period of time, like the rest of us, we do it because we see there's a long-term value. Hopefully. I keep saying that, hopefully.
Actually, we do get some form of compensation from the study fleet. And the electronic monitoring system that I get into right from the start, they give us the equipment, which if it becomes a real program, unless it already has, you would have to go buy that equipment. So maybe while it's still a pilot program, until that's a lot of incentive because it's like probably $8,000 to $10,000 worth of equipment. And as far as Jim and George is saying, there's nothing to it. They put the equipment on the boat, and I never have to touch it, so that's not really. So that's what we're seeing now, but it would be probably incentive for some guys. I always said because of my interest in all this, I do it for nothing, as long as they paid for the equipment. But you know, if you offered them some money, you probably would get a few more guys to jump in.
Yeah, I part of the study fleet kind of. I backdoored my way in actually through the Pacific States, whatever program it was, and that's how I got in on it. I've never gotten compensated for any of this. Just getting to see stuff, see the equipment, see it work, and see the results has been, in my mind, the reward, because again, it's answering questions or creating more questions. I just I like that. But I work that way. Not everybody else does work that way. So maybe there needs to be a compensation to get people in and something above and beyond. And as far as the equipment's concerned, I've done, study fleet. It's got to be simple. I said that in the beginning. And one of the things I liked about Jim and George's stuff, having the Aquatech, the Moana, I mount it on my dredge. I find a safe place where it's well protected. It interfaces with my laptop or the tablet, whatever, that Raspberry Pi in the wheelhouse. I don't have to touch it, but when I want to, I can run in and swipe the screen and get, I have a click, oh yeah, look at that, interesting. And I'll write it down in my logbook. I'll make a little note. And as to study fleet, I figured out how to, what my important things are, and I just write my whole page out and have the crew tell me what did we have for bycatch, and I write that all down also, and I look at my water temperature. But the one problem I will say with the Ruskin app, I had trouble reading, just understanding some of it, looking at it. That maybe that's just me, but just the way it was. And I had hellacious connection problems on my boat with the thing for some odd reason. I don't know why. I got frustrated and upset. And I said, here, take this back until you get another. Now I've used several different stuff. One, I don't remember what it was. I called it the Teletubby. With some silly little thing with a screen in the middle of it. We dropped down. That was an interesting little unit. But again, it's got to be something. The other thing, I'm not Lobster anymore. If I was Lobster and I had my hauler hooked up directly, it would be no big deal. I don't. I'm scalloping. I don't like to stop the boat. Fall back, dump it, get it overboard, keep going. I'm a day fisherman, so boom, 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 boom. steaming home or steaming out. No, I'm not stopping steaming out. And we're hauling it by hand. And then, well, the crew doesn't want to deal with it. And yeah, it's getting crappy. I don't want to deal with dropping and hauling it back up. And then at the end of the day, it's aggravating. So what I'm getting at is just an example of how do you keep it simple and literally happens autonomously on the boat. And that's one of the things I like about certain projects and how it's set up. I mount it on the dredge, get Wi-Fi's or Bluetooth to equipment in the wheelhouse, and I can go in and look at it. Done deal. I got a two-man crew. I'm out on deck 90% of the time anyhow. I don't have time to mess around with extra stuff. And a lot of lobster boats are single-handed, double-handed. That's just my one thing is how can we streamline things so it's simple as possible?
Yeah, that's one. The system takes, I don't know, probably took her an hour for you to set it up, and then you put the probe in your trap, and then when it comes aboard, I have to wait between 3 and 6 minutes, but it doesn't seem like much time. But it is when you got two guys waiting. You push the trap down, you haul another one, the rope's piling up. But it works, but it just takes some time. I can see in your case, if it was further away, it would take even longer. But time is money.
To follow up on that, fishing by myself, we have a part of our app is to pick a trawl, pick a number, the string that you're going to do the sampling out of every day. So if I can, I save that to the end, put the stuff in baskets or totes, and then put the boat on pilot and measure as I'm going home. But if I have to stop in the middle of the day to do a ventless trap that's like in the middle of the string of gear and it happens to have 76 crabs in it, and 20 lobsters, you're talking a serious chunk of time out of your day to do that. And it comes off my time at home. So I think some form of compensation is nice, Anna. It's probably going to have to become a norm, because I've always never felt guilty being compensated because I've got a boat, I've got the equipment, I'm paying for the fuel, the bait, and my time, and it's part of the equation of the whole research thing, but I feel pretty strongly about it, so.
Great thing. I think we have time for one more question. You've been waiting patiently.
I'll take it. Streamline data pipelines aside, I'm curious about imagery and how that might help your operations as a fisherman. I can think of all kinds of ways it could help with science. So I'm just going to trigger, like, imagine if you could put cameras on your pots, or if you, before you put any gear down, you could just drop down, have this all put on your boat and actually see what's happening down below, or actually have a live feed from, like, if you're dragging a net. I'm curious if that is something you'd be interested in.
Well, I could answer real quick in one sense. If we had cameras on our traps, we'd get very frustrated seeing how many lobsters walked in, had a meal, and walked out. We have been trying to invent the better mousetrap all our careers.
I've done live feed video with Coonamessett Farms and with Jeremy and Anna, and I think it's awesome cool. It's really great. We've seen some really interesting things. I also have used GoPros. I keep a GoPro in my wheelhouse. I have put it on dredges, and it's really cool. And the sound, I can hear individual shells going into the thing, and sometimes you see some really entertaining stuff, and sometimes a lot of boring stuff. At the CFRF, we do dredge projects, the Enviro dredge and other stuff. I Mickey Mouse something to see if we can make the damn thing catch, and it's great to have a camera on it once in a while to see, oh, I see what's wrong now, what's happening. As an aside, the Enviro dredge has got like an English beam that's got a big round beam with wheels on it. And I was noticing juvenile scallops are highly active. And one thing I learned with video work, whereas the larger scallops much less so. And I noticed a lot of scallops whizzing by the camera, not going into the Enviro dredge. So one of my things was, well, let's try to tow it faster. That'd be better, right? That thing's not really made to go fast, but you know what? In the end, it did work. But still, you see things shooting all around the camera. I was like, huh. What I realized was that 10-inch pipe was making a hydrofoil type effect that was throwing the stuff up and over the dredges. And already juvenile scouts being active, of course, we didn't want to catch, part of it was to get rid of juveniles, but it was getting rid of everything. So, but to be able to see stuff like that, really cool. Ron has used a lot of GoPro video. I've seen, like, on the Celtic, running dredges through rock piles that make you shudder, you know, and other stuff when we were doing the turtle dredge studies and learning how to develop. But all that stuff is really cool and that is applicable.
That was my question, but don't buy from them. There's a hard problem. That is my question now. Oh, sure. How does that?
Not the data guy.
Yeah, I don't know if it, we won't do that, so we're not going to answer your question, I'm sorry. So I think we're going to wrap up and move to the breakout sessions. Is that where we are in the schedule right now? So I just want to give a round of applause to these gentlemen. Thank you for your time. It's never easy to stand up there. Oh, do you have fishermen with a, sorry.
I just wanted to ask one question to go into the compensation discussion, and that is just simply, would the scientists in the room work for free?
Yep. So with that, yep. We're doing to do anything right now? We're taking a break. Is the tables labels? I don't. Okay, so there's going to be a quick coffee break here. And thanks again, guys. I really appreciate it. I owe you all a beer.